Right, hi guys. If we can, if anyone downstairs can hear me, if you want to start making your way back upstairs, we're going to carry on with the speeches now. Just give it 2 secs. Give it 2 secs. Let them wait. Right, so next up we have a panel which is discussing are L1 app chains and roll-ups really that different? So if I can welcome up Neil Somenham, CEO of Eclipse, Albert Chon, CTO and co-founder of Injective Labs, Bodu, the co-founder of Polymer Labs, and moderated by Artem, co-founder of Oak Invest. Mics should all be on already. Okay. Yeah, if you just keep them closer to your mouth so you can. Right. Let's start. Let's go. Carry on.
Hi. Hello, everyone. People can't hear us, but it's fine. Welcome back. So we will talk about app chains and rollups. We will see the difference between them, and we have a great panel to talk about it. So just first of all, could you guys please present yourselves and tell more about what you're doing?
Hey everyone, my name is Bo. I'm a co-founder at Polymer Labs, and we're connecting everything with IBC.
Hi everyone, my name is Albert. I'm the co-founder and CTO of Injective Labs. Injective is a layer 1 blockchain built for DeFi.
And I'm Neil, building Eclipse. And we're building app-specific rollup infrastructure, one of which is a chain that we've deployed for Injective called Cascade, which will connect to the rest of the Interchain via what Bo is doing at Polymer.
Yeah, and so let's take a little step back. A few years ago, we only had some solutions. We only had, you basically build a protocol on Ethereum, or you build an L1 which is more scalable, which is faster, which is cheaper, etc., etc. Today we have more solutions. We still have the L1s, but we have L2s, we still have protocols, we have cross-chain protocols now. And we are seeing some upchains within some ecosystems like Cosmos, Avalanche, Polkadot, Polygon. However, the first question that I have for you guys is that with all these developments, all these new chains launching, we're still seeing a lot of fragmentation of liquidity. Do you think that is this a problem for the ecosystem, and how could we solve it?
Yeah, well, to me, the best apps for app chains are ones at this point that don't require a lot of composability outside of their chain. So that's things like games, physical infrastructure networks. There's some DeFi applications like exchanges that make a lot of sense to be on their own chain. In the future, of course, what Bo is doing and a few others like Catalyst is some kind of shared liquidity primitive across different chains. I think that can do a good job of reducing the liquidity fragmentation. Right now, I typically advise that those types of apps that really need to go cross-chain on a regular basis just probably stick to a shared chain.
Yeah, I think it's quite interesting to see how fragmentation will evolve. And one recent example will be, I think, the Kava USDT versus Noble USDC. And I think adoption of either of these two in the short term will be driven by incentives, but in the longer term will be driven by network effects. So it's kind of that classical race to see who can get more adoption in the short term, maybe with incentives that are unsustainable. And yeah, we'll see then that whether that could drive network effects such that the switching costs for these assets is too high because they're too sticky or not. But yeah, it's an interesting space to see.
The liquidity fragmentation problem is definitely exacerbated by growing number of app rollups, rollup frameworks. It'll continue to fragment. It's somewhat solved at the lower layers by standardizing on interoperability between chains. It can be solved on the upper layers by liquidity networks, as Neil had mentioned. You can have connects protocols. You have protocols like Catalyst that can kind of bridge liquidity across chains. Native issuance of tokens like USDC is also very important. The security and the safety of that liquidity as it moves across different networks is paramount.
Yeah, I think stuff like account abstraction has some potential to better solve it, in that now you just authorize user ops to be executed on different chains rather than actually moving your money. Because right now I think we're in this weird situation where, especially if you end up with hundreds or thousands of app-specific rollups, your money is going to be all over the place. which is just going to be really cumbersome to keep track of.
There was a nice conversation I had with Irene from Layer 0. So they are working with Aave to develop portals, which would allow you to have collateral on one chain and, for example, borrow on another chain, which solves the problem of bridging assets, creating smart contracts, which can then be exploited. Do you think that this fragmentation of liquidity could be solved through protocols directly rather than bridges or blockchains themselves?
That sounds like a very different thing from like the native issuance, like liquidity networks. I mean, the question of security comes into mind as well when we talk about Layer 0. But I think you can solve some of these things at the protocol level in terms of safety. If we can have like state validating or transition validating bridges between different chains, that's one up. If you have trust minimized interoperability between bridges that settle onto a single layer 1, that's also very nice. If in the future we're able to do some sort of like cross-chain atomicity, that can also help this as well.
Yeah, I think solutions like escrow IBC, where you essentially have a liquidity provider, a market maker for these tokens to take on some risk, are more band-aid short-term solutions that are expedient, but they have their set of trade-offs. There's a fee associated with it, and black swan events do happen. So it's not really, I wouldn't view it as part of like a foundational system that we should base our bridging off of.
Yeah, on the point about atomic composition, I think that works for multiple, like if you're okay with the atomic composition occurring over multiple blocks, but single block atomic composition probably won't exist, at least in the near term for now.
And so let's get back to this subject. Do you think that users are more likely to use a rollup that has its own blockchain rather than relies on the security of an underlying blockchain? Or do you think it's that users will use it if there is a value proposition?
Wait, could you rephrase that question one more time?
Yeah. So, for example, let's say you have an app-specific rollup, which has its own blockchain, or you have a rollup which relies on another blockchain. For example, NL2 on Ethereum, which relies on the security of Ethereum and only scales the blockchain and lowers the cost. Or an app-specific DEX, for example, which has its own blockchain, like we have Crescent, we have Injective, actually, we have some other protocols as well.
Yeah, so whether there's any preference on the part of users for layer 1 app chains versus app-specific rollups.
Yes.
Yeah, I think as an app-specific rollup, like the way that I used to think about it was it's essentially the same. It's its own chain. But it's true that there's like implications on the social sovereignty if you're an L2 directly on Ethereum or something like that. And that might actually be desirable if you want your users to be more Ethereum aligned or something like that. But in general, I still do think of it as a separate chain, meaning that you have to bridge money to the chain. All the same issues or like the bottlenecks that L1 app chains experience are the same ones that app-specific rollups experience too.
I think that end users don't really care, and two good examples are one, the Axie Infinity Ronin sidechain. Thousands, millions of Filipinos and others used Axie Infinity without knowing or caring that it was, a validator set of 7, of which, one of their engineers, were just running on their cloud servers, which actually got hacked. So it matters until, it doesn't matter until it matters, which is when, the protocol gets hacked because of weaker security guarantees. But conversely, I think two other examples that didn't get hacked are, Polygon, the POS system, and Binance Smart Chain, right? Which isn't an L2, but can be viewed in that similar lens. And what we see is that end users don't really care. But I think the people that do care are developers, because you don't want to launch your protocol on something with a shaky security foundation, right? And you can even see that materialize in the choice among developers between Arbitrum versus Optimism, right? Even though the difference here may be minor with, the recursive fraud-proof system versus executing the entire transaction, you can see that because of this marginally better security property that developers choose to go there, which in then turn creates network effects, which in then turn incentivizes users to go there because of various just availability of new things to use.
Yeah, I think to comment on the security point, there's some trauma with bridging. Like there's some liquidity trauma with all the bridge hacks, and there's with greater liquidity safety, we'll see like liquidity flow outwards a bit more. I think we see a lot of liquidity flow to layer 2s, and it kind of dries up as you get into app chain land. And on the UX front, I would say users care a lot about UX. That's what they interact with. If an app chain or an app chain ecosystem has greater UX, it can get there faster or more quickly than working off of an L1 or an L1 rollup, then it could make sense. An L1 rollup optimizes for cost as a UX factor. An app chain optimizes for the ability to experiment and iterate faster. So if you can innovate and experiment faster on the app chain side, you can make a competitive product to bring in those users. Or if you already have users and you want to further optimize the experience like a DYDX.
Yeah, I think that Bo's right in identifying that the real risk is just the bridge. Because in some sense, the L1 app chain has security advantages because you can roll it back and you can fork it, and you just can't roll back assets that were already bridged out of the chain.
And let's get on with this panel. So, Polymer and Eclipse, you're both working with Celestia. One of you is providing IBC services, one of you is providing rollup services. And so as the question is, what is the difference between the rollups and L1 app chains? What are the different services that you provide here for Celestia, for example?
The difference is primarily the unit economics of the chain, where for a full layer 1 blockchain, you have to get 100 validators, and they're all spending money to run each month. And you have to, for a proof of stake chain, you have to actually put up stake. Whereas for a rollup, it's more cost efficient from that perspective, but there's a marginal cost associated with each transaction, where now you have to post it to a layer 1 blockchain on Ethereum that's a base cost of maybe like 10 to 20 cents per transaction.
Yeah, to add on to Neil's point, it's the difference between needing to execute one program instruction over a single node or over a large number, maybe let's say 150 nodes. The cost of that is different, and then you have to add in consensus, you have to add in all these other mechanisms that add real costs, real computational costs, like not arbitrarily priced costs, but real computational costs. Also, rollups inherent security from the DA layer that they post to. So if you have a number of rollups built across the same DA layer, they have secure liquidity flow across them. Because you can prove fraud as long as the DA is made available, the block is made available, someone can come along, take that block, download it, re-execute it, generate a fraud proof, and secure the communication between these rollups.
And as we were talking about it, so
Like a layer 2 or like your own rollup?
Yeah, comparing to a rollup.
Yeah, I mean, I think it's quite clear. One is security. You have to bootstrap your own validator set, and instead of relying on common infrastructure like RPCs or tooling, et cetera, you have to kind of create all of that yourself. Much of that is expedited by using the Cosmos SDK, for example, on the tooling side. But you basically are now responsible for your own network. So that's the burden that you bear. But in contrast, you get many benefits. You have the full control over the network. At Injective, we, for example, can make many optimizations. Like, for example, doing matching orders in parallel. We can leverage concurrency and Go routines to use all the CPU cores. You can do things like use GPUs even. And for example, you can have compatibility with MetaMask and Ethereum accounts because you have control over what is defined as an account on your chain. So you have the flexibility to introduce all sorts of new things that would be very challenging to do if you were just using the EVM as an example, or an EVM-based rollup, because you have control over every layer of the stack, from consensus to your application layer to even like lower level networking if you do want to modify things there. But of course, like with great power comes great responsibility. You could also fuck things up. So yeah, that's mainly the trade-off that exists.
Well, it's something which is really close to the rollup thing today, with especially the shared security, because you have to rely on the Cosmos security, which makes your validator still useful, but you have this additional security coming from the Cosmos validators?
Yeah, I mean, it depends on the design of the rollup. It could, just be a sovereign rollup, for example. One design that we are exploring is for the validators on Injective to kind of enshrine the rollup by keeping track of the block headers of the rollup and then attesting to them on Injective. And one reason we might do that is so that we can have fast finality, essentially, and not have to wait for the optimistic fraud-proof window. But yeah, of course, different rollups, you can take different designs.
Yeah, and Bo, maybe you could even chat a bit about what are the options for a rollup to get fast finality or to be compatible with IBC?
Yeah, there's a few options. If you have a rollup, then if you want to verify that the state transition was correct, you can either, let's say, use the sequencer, which I believe a lot of protocols do. And the other option is, as Albert mentioned, you can enshrine essentially a client, an IBC client for that rollup that does the verification. For this approach, you would need to run, as Albert mentioned, a full node of that particular rollup. If you don't want to do that, if you don't want to incur the cost of doing that, you can trade off a little bit on the security side and cost side by saying, I'll trust the signatures from some attestation committee, whether it's the sequencer. Additionally, you can have like additional validation mechanisms like EigenLayer, where you have some third-party attester that perhaps if you're in the ecosystem already, you already trust. So for rollups on Ethereum, perhaps bridging over, you can say, I can have EigenLayer restakers attest to the rollup transitions, so I can use the safe L2 head or the L2 head of the rollup that has already published DA and leverage L1 finality instead of true rollup finality for bridging.
Yeah, I guess for the EigenLayer solution there, you would still need some way to verify an incorrect state transition on-chain in order for the EigenLayer slashing to work. Whereas for the committee ideas, like the attestation committees, there's not really slashing that occurs per se. It's more just that all of those full nodes are also running a full node of the rollup.
Oh, you could still have slashing for the committee-based approach as well.
Yeah. Okay, yeah, I guess the rest of the committee slashes them or something.
And so let's talk about the blockchain trilemma. So we have the three elements: decentralization, scalability, and security. For the rollups which don't have a token, so this would be a question for you, Neil. How would you implement governance within the rollup that doesn't have a token?
Yeah, kind of like two separate questions, but on the first part, on the trilemma, I think the right way to interpret that, because there's a lot of wrong ways, I think, to interpret the blockchain trilemma, but the right way is that if you measure decentralization by the cost of running a verifying node, then in general, to handle more throughput, you need a beefier node. And therefore, it's more expensive to run a fully verifying node if a full node's your only option. Now we have like other ways to verify. So I think we actually have expanded the blockchain trilemma, or like we've expanded the efficient frontier of what's possible on chain. So that's one thought. And then the second part is, how do you have governance? Without a token, you'd have to have some kind of elected governance or delegated governance. You have to just choose some folks, some group of entities, or maybe Bo or Albert, if you guys have thought about that a little bit. I'm not sure what that would look like.
I'm not sure you need a token for rollup bridging. You can verify a rollup.
This is for governance.
Oh, for governance. Yeah. Oh. Yeah, I don't have too many comments on the governance side, but I think the token governance maybe can be used for like elected voting. So like you can have by like stake weight. It's kind of like a meta POS system, a voting system where if you accrue a lot of tokens, you can accrue like different like stake weight to like move the rollup, decide the rollup settlement, decide the rollup internals on, do I settle to ETH L1, which I'm paying a higher cost? Do I settle to EigenDAI, which would be a lower cost? Or do I publish DA to any of these locations? Yeah.
And today, if you want to build your own solution of scalability, so it can be an upchain or a rollup, for which one would you choose for upgradability? Which one would you choose for scalability, where you have to have a high throughput, sorry? Which one is more suitable for each category?
Yeah, it depends how you define scalability, but if you're defining scalability by throughput divided by the cost of running a node, then I don't think it really matters whether it's an L1 versus an L2. Like either, I guess you could rely on, sometimes when people have an L2 on Ethereum, they're saying, oh cool, I don't have to run a full node of the L2 anymore. But implicitly it's because the L1 nodes are the ones doing that verification. So if you want to directly verify yourself, you still have to run a full node. So yeah, I think if they're equally scalable, and then the second part was upgradability. I think in either case, you'd also have to get, it's probably easier to upgrade a rollup, I think, because it's fewer nodes that need to update.
You want to add anything?
Yeah. I think as a developer building an application, if you care a lot about scalability, rollup is probably a better approach. If you care about customizability, you want to build on a platform where the cost of innovation is low. The cost of innovation on rollup, especially rollup frameworks as they are today, is quite high. I think there's a lot of marketing that goes behind stacks like the OP stack. It's not clear to developers like what they can build, how flexible is it, how easy is it to build. If you wanted to, let's say, like add a virtual machine, a new one, that's not the EVM to the OP stack, it would be incredibly difficult. There's a whole number of things that you need to do, because in order to prove fraud on-chain, you need to have stateless access to read all the state, both in memory and on disk, in the fraud-proving VM that sits on the Ethereum L1. There's a whole pipeline of infrastructure that you have to build to make this happen.
Yeah, so I think you can even argue that upgradability in L1s would be easier just because, like for example, a Cosmos-based L1, because you have sovereignty over the system. You aren't constrained by having to live in the constraints of having something be fraud provable. And particularly, I think the scope of modifiability kind of really relies just on opcodes that you can add to the EVM, which is extremely limiting, versus any arbitrary code in Cosmos as an example.
Yeah, but I guess the way that like OP stack, for example, is written right now, you could theoretically add anything to it. The fraud proving, I think, is actually the easier part, even though it's not enabled right now. In theory, that's not like a constraint. I think the only difference in upgradability is what you're able to upgrade. Whereas for your L1, you can upgrade things related to the consensus much more easily. Whereas for a rollup, you're pretty much restricted to the execution layer.
Yeah, and so last year we had this narrative of the L1s, that alternative L1s, which were going on for a long time, but today the focus has shifted to the L2s. And the thing is, we have all these incentives, we have all these companies building on L2s now, we have Consensus, we have Coinbase, which are building L2s, and so people are starting to look away from the L1s. And so how do you bring how would you bring the interest back to these L1s which already exist, which already have a solution that has proven to be secure? But today everyone is looking at TVL, everyone is looking at where developers are, everyone is looking at where the innovation is. So how would you bring back the interest to these L1s which are already in place?
I mean, I don't know if that's a good characterization. I think developers should find the solutions that work best for them. For some teams, an app chain is the right thing to do. It's the right set of trade-offs. For other teams, especially if you are building on, let's say, Polygon or Arbitrum, and you want to have your own, rollup, and that's easier because you can just port all of your code over, and you want to have an ecosystem that's also in Solidity. It makes sense to do your own L2. So yeah, I think more than like a top-down, like this is what the cool thing is. It'll be more of an emergent phenomenon where individual projects and teams will decide what makes sense for them. I would say until now, or building your own app chain seems to be more accessible to individual teams versus creating your own rollup. But that will soon change over the next 12 to 24 months with companies like Eclipse making it easier and easier to do.
Yeah, I agree with that characterization that like for a given type of application, like given their throughput expectations and what their ambitions are for their project, there is a correct solution on whether it should be an L1, an L2, deployed to a shared chain. And it's all about Just what do they prefer given the objective differences in those architectures?
Yeah, there's a cost of innovation and a cost of security perspective here. Cost of security is related to liquidity. Cost of innovation is related to how fast you can iterate and develop more innovative features than your competitors. I don't think many of these like non-generalized rollups onto ETH L1 are going to make it. I think a lot of it comes from the DevX standpoint. I kind of spent a lot of time working on the infrastructure side, so I think more about developers first. So for developers, you want to pick a framework that's easy to develop with. I think Cosmos SDK, where it sits now in terms of DevX, in terms of customizability, how clear is it to do the things that you want to do and how easy is it to do the things that you want to do, is still like leaps and bounds ahead of these other rollup frameworks that are on like ETH L1, like OP-Stack, Arbitrum Nitro. I think there's a 4 to 5 year lead on the SDK side. I think if the SDK continues to innovate and we're able to customize it so that we can deploy to different environments, kind of like a build once, deploy anywhere approach, the L1 app chain ecosystem and the ETH rollup ecosystems are going to merge and be like highly compatible with one another. Like if you want to configure your app to be a rollup, sure. If you want to configure your app to be an L1, just change the configuration and it'll happen. And developers will be able to build the things that they want and have the flexibility and freedom to do so and innovate.
I think one interesting development may be that with the advent of shared sequencers on L2s, if this gives way for atomic cross-rollup composition, then will the benefits of deploying on a rollup versus an app chain be much greater? Because even with app chains right now, you have an asynchronous programming model with IBC that's quite awkward and clumsy, and you depend on relators to interact with. Perhaps if you have 5,000 rollups on the same shared sequencer and you have atomic composition, this will be compelling enough and for applications to choose to be their own rollup versus being on an app chain. But that is yet to be seen.
Okay, guys, we have to wrap it up. So please give it up for the amazing speakers. And thank you all for sticking around.
Right, amazing, thank you. Sorry about the slight delay with the power, but we're back up, we're back running, so we'll get back on track. I'd like to introduce the next speaker, Ethan Butchman, founder of Informal Systems. If you'd like to come and join me on the stage, please, and start your presentation. Thank you very much.
Hello, testing. Is this good? Oh, yeah. Now that's sound. Hey, quiet down in the back. I'm talking. All right? No one gives a shit. Okay, cool. So I'm Ethan, co-founder of Cosmos, nowadays running Informal Systems. We still do quite a bit of Cosmos dev. My timer's not running, so I'll just talk indefinitely, if that's cool. Yeah. Get some extra seconds in there so I can banter with y'all. Yeah, so you might know if you follow me, I'm super into money, monetary design, history, theory, all this sort of stuff. We at Informal Systems, we're one of the lead Cosmos developers. We work on Comet, Cosmos Hub, parts of IBC. We really want to make this technology real for the real world and have real world impact. And so we've been working on a project we call collaborative finance, which is our sort of response to DeFi and how to actually do it right and informed by theory and history. Now, I was invited to give a talk at the Modularity Summit on Saturday, and when I told the organizers I wanted to talk about Ko-Fi, they said, well, that's not on topic. So I said, okay, fine, I'll talk about something else, and then I just told them the title was Modularity and Monetary Design, and then of course they were thrilled, but it was still very much a talk on Ko-Fi. Now, I gave that talk on Saturday, And it went so well, and everyone was so happy that they were like, you have to give this talk again at Nebular. So that's what I'm going to do. So I'm going to talk about Ko-Fi. Yeah. All right. Represent. Yeah. So thanks for having me. Thanks for sitting here and not being super loud and talking to your friends in the back like all these other jerks. But maybe they'll pile in once they start to see all the excitement we're building here. So I've long felt that money is the killer app of blockchains, of crypto. It's the ultimate multi-stakeholder computation. But to date, we still haven't really figured it out, right? Very few people are really using cryptocurrencies as a payments technology. It's mostly driven by speculation and gambling and all this sort of fun stuff. And so we want to understand that and try to do something about it. And to do that, we have to really understand what money is, what money's for, what money's about. So let's talk briefly about that. I like to say that if home is where the heart is, money is where the payments are, okay? Money is for payments. It is for denominating and discharging debt. That's what payments are, right? You incur some debt, and then you pay it off. That's what money is all about. I'm going to use the word discharge over and over again throughout this presentation. Discharge just means to settle debt, to pay down your debt, to reduce your debt. But I'm going to use the word discharge because it's more precise and because I want you all using more precise language, okay? So everyone's familiar with the functions of money. We have the unit of account, that's for denominating debt, right? How much debt exists. The medium of exchange is for discharging debt here and now. And the store of value is for discharging debt elsewhere or later, right? And so we can understand the different functions of money in terms of what they contribute to denominating and discharging debt. Now, so here's kind of the core problem we have, that armed with the unit of account, once we have a unit of account, a common measure here, we can denominate unlimited amounts of debt, right? There's no limit to how much debt we can create with a unit of account. The problem is, how can we ensure that we're going to be able to discharge it all, right? Once we create all this debt, how do we know we're going to actually be able to pay it all down, right? And in some sense, there are certain kind of debts that are ultimately never really meant to be fully paid back, right? Like government debt. The government doesn't want all their debt to be fully paid back because then the whole system might collapse, right? And so we're currently operating in a sort of monetary system based on a kind of debt that's designed not to be paid back, which is really a big problem. But so we want to think about this more fundamentally and think about essentially this. If we're going to go out denominating all these debts, how can we ensure that we can reduce them all, right? And a few thousand years ago, they would have these jubilees where they would just forgive all the consumer debt every 7 years or however often, whenever there was a new king, to sort of execute their sovereign power and show we can reduce the debt. So this problem of how do we ensure that we can discharge all these debts, this is what we call liquidity, essentially, right? The ability to discharge your debts when they're due, yeah? Liquidity is not, how much slippage you're going to get when you trade one shitcoin against another, right? It's not how many assets are piled into this exchange or flowing over IBC. All that stuff is great. It's very important. But fundamentally, liquidity is about this problem. When your debt is due, can you pay it? If so, you're liquid. If not, you're not. You're done. You're out of business, right? And you can be solvent. You can be insolvent for a long time. But liquidity kills you quick. Yeah, liquidity is the thing that takes you out. And the reason we call exchanges and all this stuff liquidity is because the whole purpose of that is to acquire assets that you can use to discharge your debts, right? So how do we solve this kind of problem in the real world? Where do we manage liquidity? Well, that's where a payment system comes from, right? And I'm going to define a payment system as a set of obligations plus some liquidity source that you can use to discharge debt. Yeah. Now, if you think about that definition for a second, you might realize, well, wait a minute. None of the things I think about colloquially as payment systems, fintech, blockchains, banks, et cetera, actually satisfy this definition. And why not? Because they don't actually represent the obligations. They're just all about the assets, the asset transfers, right? And so that's something, that's a big problem because the obligations are really where all the important information is. That's where the trust relationships are. That's where we extend credit. That's where we actually engage in, human commercial activity. And the payment is just the other side of it, right? That's where we settle up later, right? But if we're not looking at the obligations, then we're missing actually most of the story, right? That's the foundation of a payment system, are the obligations, right? So let's offer a brief critique, let's say, of existing payment systems, yeah? Now, we're actually writing a white paper about Ko-Fi, actually multiple white papers because the scope is kind of massive. So everything I'm presenting here is from one of them. And we're not going to have too much time to go into all the details, but just kind of briefly, let's lay out a sort of high-level critique of existing payment systems. Yeah. So first of all, none of them are designed from first principles. The banking system has just been cobbled together over the centuries, responding to the needs of bankers and traders and governments and crises. They keep having these recurrent liquidity crises. Blockchains like to claim they're driven design from first principles. Maybe they are from like cryptography, from distributed systems, but even on they're just going to say it, multilateral trade credit set off, right, mother? Yeah. No, obviously not. We'll call it something much more natural. But the idea is that we can connect to the sort of existing capitalist, asset-based, liquid economy, and we can leverage that to actually benefit the real world and the real economy, right? Sounds like some sort of magical thinking, but it's very real. Planet, the most future-proof. IBC makes assets available from anywhere, and we need to connect all that stuff in to really realize the CoFi vision. Okay, so let's talk about actually the structure of the payment system. I've sort of motivated the design. I'm probably running out of time, but that's all good. So the missing primitive, the fundamental missing primitive, is the obligation. Okay, and we're going to spend about a minute talking about balance sheets and accounting. I hope none of you are too afraid of that. Accounting is really fundamental stuff. I think the world would be a better place if we all thought more about accounting. If we were all trained as accountants, we'd probably be better off. So here we have some balance sheets. And a balance sheet has assets and liabilities. On the left, in panel A, we're showing an asset transfer, right, from Alice to Bob, right? Alice is going to transfer. She has $20 of assets on her balance sheet, and she's going to transfer it to Bob. Now the $20 in assets are on Bob's balance sheet. So there's no liabilities involved. There's no debts here in the image, right? Very simple. This is what you do every time you make a payment. You transfer some Bitcoin or some atoms. Very simple. Now on the right is something a little bit more interesting. This is what an obligation looks like. You have a liability on Alice's balance sheet. She owes Bob $20. That's a liability. And corresponding to that is an asset on Bob's balance sheet, right? That he is owed $20 from Alice, right? So we call one the accounts payable, if you will, and the other the accounts receivable. You'd probably be familiar. This is all very, very, very basic stuff, but it's important to be thinking in terms of balance sheets because that's where we can actually understand the structure, the underlying structure of the payment system and the collection of debts we need to actually discharge. If we don't look at the balance sheets, then we're going to be surprised when everything blows up, which is exactly what happened in 2008. Now, there's two things I want to point out about this. First of all, when you make an asset transfer between two parties, like we have on the left, in general, almost always, there's actually a pre-existing debt that you're discharging, right? So it's not shown here, but Alice probably owes Bob $20 already, right? And now she's going to settle that debt by transferring the $20 to Bob, right? So we don't represent those obligations, those liabilities on our blockchains or in most of our payment systems, and that's a huge problem because there's a lot of really profound stuff that we can do if we start to pay attention to the structure of obligations, and that's what we're going to get into. The other thing I want to point out is that obligations, declaring an obligation, is actually a permissionless operation, right? If I declare that I owe Gary Gensler $20, there's nothing he can do to stop me, right? The same way, if I have his address, I can send him $20 of a shitcoin, and there's nothing he can do. It's permissionless, right? And now he's as much of a scammer as the rest of us. It's the same thing with an obligation. If I declare I owe you $20, who are you to stop me? I owe you $20, and that's a fact, right? So it's a permissionless sort of expression, an intent, if you will, to pay. And we put these things together, and we end up with a network of obligations, right? So we were just showing a very simple example of a single obligation, but we really have a much more complex network, obligations all over the place. There's all these structures. You have chains, you have cycles, you have hubs in the network, and so on, right? And what's really profound about this, if you're thinking ahead, or if you've heard me talk about this stuff before, you might realize that if we have a cycle of obligations, you can actually settle all of that. You can discharge those debts without any money at all. Okay? Let me say that again. If you have a cycle of obligations, you can discharge those debts without any money at all. I mean, it's a brutally obvious, intuitive concept, right? If I owe Brian $10 and then Brian owes me $10, we don't need any money to settle the debt. We just do set off. We just offset it and we say, all right, we're cleared, right? But if we're not aware of the actual network structure, then we might be stuck in a deadlock, okay? Now, there's a couple more concepts I want to introduce to actually motivate all this. If we have this, this big network of obligations, we're trying to discharge it all, we're trying to settle all these debts. What are the different ways we can settle? Most of modern finance is based around something called novation, right? Where you sell your debt, right? Oh, someone owes me money. I don't want to deal with collecting. I'm going to factor it off, right? Someone's going to buy it off me. I'm going to pool a bunch of debts together into some securitized debt obligation, and we're going to sell it off to pension funds in Germany, and we're going to make a bunch of money on the fees. The whole financial system is based around this sort of like selling off debts. We call that novation. You're changing the structure of the obligation graph, right? You're disrespecting the underlying obligations and the trust structure, right? And that leads to a huge amount of problems. The economists claim, oh, it's reducing risk, and the people who can take the risk, are taking it, but nobody knows what the hell is going on. And obviously, all of that blew up in 2008, right? So what we want to do is something different. We want to say, well, let's try to settle as much debt as we can without using novation, right? Before we sell off a debt, let's see what else we can do. Well, there's a few things we can do. We can do set off, which we just talked about, which is really just clearing, right? If we have a cycle of debts, and if we're aware of the cycle, then we can set them off, right? The other thing we can do is assignment, which is really just transfer. We just have fancy terms for things. We'll call it assignment. I owe you 20 bucks. I transfer you $20 worth of Bitcoin. Now my debt is cleared. That's assignment. Very straightforward. But there's a very interesting thing you can do, which is called overdraft, right? Now, you might be familiar with credit lines. This is basically a credit line. You go to the bank gives you a credit line. You say, all right, I'm going to pay my bills by drawing on my credit line, right? So what you can think about this as, if you have a positive balance of something, you can do assignment. If I have a positive balance of Bitcoin, I can transfer some to you. That's assignment. I can settle my debts that way. Or if I have access to a credit line, to an overdraft facility, I can basically go into a negative balance, right? So assignment is positive balances. Overdraft is negative balances. And with overdraft, you can, when I draw on a credit line from a bank, the bank is actually creating new money when I draw on that credit line. New money is being created. Now, banks are allowed to do that because they have licenses from the government, right? But why should banks get to have all the fun? What we want to do is restore the capacity to issuance to individual communities to be able to create money on demand when necessary to discharge their debts, but in a sustainable way, not like irresponsible, unsustainable governments. But it doesn't have to be done with money creation. It could also be done without. A bunch of investors could come together. They could pool their assets into a credit facility that businesses can then draw on, right? And so this is essentially part of what we're building with Ko-Fi, is a platform that existing liquidity protocols from all across the Interchain, all over IBC, can connect into and provide liquidity in order for real businesses to discharge their debts. Okay. The last piece we need to put this all together is a couple other, at the Modularity Summit, it really mattered that I talked about intents. Here we're, a little bit less pretentious, so, we can just think about, the actions we want to be taking, right? But, they really are intents. So we have obligations. We've talked about that. A tender is basically a willingness to pay with a certain currency, right? I'm willing to use Bitcoin at this price to pay my debts, and an acceptance is a willingness to accept a particular currency, right? I'm willing to accept Bitcoin at this price or atoms at this price in payment of my debts. So we can put this all together into essentially a graph, right? We have the thick lines are the straight lines are the obligations, right? These are people that owe each other. At the bottom here, what we're representing is basically, oh, do I have a, no. Oh, no, you can't see it. All right, too bad. At the bottom here, we have what we're calling a liquidity source. It could be atoms, basically. And we break it into 4 nodes, right? So we have the assignment node. That's the A on the left. Those are the positive balances you can draw on. We have the overdraft node. Those are negative balances you can draw on. And then we have repayment and deposit nodes where people accept the currencies back to, right? And so essentially, we have firm A on the left there and firm B on the right, and a bunch of nodes in the middle, right? And so firm A owes the middle node who owes B. A has a tender saying, I'm willing to pay in atoms. Firm B has an acceptance saying, I'm willing to accept atoms. And in the middle, the guy in the middle is just going to get set off, right? So no money actually has to move through the chain. It only has to move from the beginning to the end. So A's atoms, even though A and B don't have a relationship, by mapping out the structure of the obligations, A's atoms can be transferred to B, and all of the debts in between can get set off, right? Very, very, very powerful. Now, we can actually combine different sources of liquidity. We can have fiat and crypto, and we're showing a similar thing. We have a chain ABC. We have another chain DBE. Now, A and C are willing to use fiat, and D and E are willing to use atoms, and B isn't willing to use dirty fiat or shitcoins at all. B only wants to settle in gold bars, right? But there's no gold bars available for settlement, and so B will accept set-off notices. But what happens here is because A and C are willing to use fiat, and D and E are willing to use crypto, atoms, let's say, and B is in the middle, B's debts get reduced without him having to touch fiat or crypto at all, right? So real people's debts can be reduced without them having to touch any currency at all, simply because there are other people in the network willing to touch that currency. So if there's a small number of people willing to pay in atoms, and a small number of people willing to receive atoms, and there's a large number of other people in the middle that don't want to touch atoms at all, they can still benefit, right? And real debts can be reduced because of a small number of people willing to use atoms. So this has really profound consequences, because it means we can start to use cryptocurrency. See, normally, if I want to make a payment with a cryptocurrency, my counterparty has to accept it, right? I say, I owe you money. Will you accept atoms? And they say, oh, they're kind of volatile. Maybe I'll take some USDC. Something stupid like this, right? But it's never going to work if we have to have that dumb negotiation every fucking time. So what we want is for the people who really care to be like, yeah, I want to pay in atoms. I freaking love atoms, and I want to pay in them.
In 2013, it was already there, right? The idea to switch to proof of stake, even though it ended up taking a very long time. And of course, the Tenement white paper was published in 2014 as well. The first kind of modern proof-of-stake networks where you'd have slashing and the kind of security guarantees were created in 2019. So it was Tezos and Cosmos, basically the first two of those networks that launched. And of course today, right, I think a huge part of the crypto economy is secured by proof-of-stake. You know, CosmWasm, we started in 2018 as one of the first proof-of-stake companies, but a lot of the companies today that are, you know, prominent proof-of-stake started around then when Cosmos got started. So this is before the Cosmos launch. And, you know, today we run an infrastructure around 40 different networks. We, you know, with over $1 billion staked. And, you know, have around 140,000 people or accounts staking with us. So the staking economy today, right? So you have around 109 billion that's staked right now. And if you, so the total crypto market cap is 1.2 trillion. And if you exclude Bitcoin, if you exclude the stable coins, you're down to around 500 billion. So this is around 20% of the entire crypto market cap. If you just exclude those two categories is staked at the moment. And around 20% at the moment is in liquid staking. And I'm going to talk a bit more about liquid staking in a bit. Of course, almost all of that liquid staking portion is on Ethereum. And then if you look at the total rewards that have been paid so far is around 10 billion. And almost all of that, or you know, the vast majority of that comes from new token issuance. And then, of course, the other categories are gas fees that people pay for transactions using chains and MEV. I think with gas fees and MEV, once again, these basically, you know, vast majority come from Ethereum, and those categories are very low on other networks where it's predominantly token issuance. So I think at this point, you know, staking has become one of the largest crypto industries. And yeah, so yeah, what's also worth noting, right, is that staking is this term that's being used, but it's being used for a lot of different types of mechanisms, right? There's a big differences in how staking works. So for example, if you just take Cosmos and Ethereum, right? In Cosmos, as we all know, you can just make a transaction, choose a validator, delegate. It's very easy. You can do it with any amount. Validators can have any amount staked with them, right? There's no limit, which is very, very different from Ethereum, where basically it's 32 ETH per node. You know, if you have more ETH, you need to spin up a new node. If you have less than 32 ETH, you can't stake it. So there's no in-protocol delegation. So there's a big differences here. And I think this is also expressed when you look at sort of the type of staking products that are being created, and that's, you know, the diversity here is changing a lot. Like just if you look at a few of the things that we are doing, so okay, you have delegation, which we all know from the Cosmos ecosystem and you're all familiar with, and then, you know, white label validators, where basically, okay, you're running a validator on behalf of some other entity, right, on their name. So this is also one thing that happens. Liquid staking, I'm going to talk more about that. Or then kind of institutional type products where, you know, building APIs and integrating with exchanges or wallets or different types of places that have their own customers and want to offer staking, you know, in a smooth way for them. So let's talk about some of the main, you know, some of the main trends in staking at the moment. So one is liquid staking, right? Again, the idea of liquid staking has been around for a long time. I mean, we wrote a paper at CosmWasm about liquid staking in 2019 that I think was the first one to sort of mention the term. But again, the idea was, actually, I think in the Cosmos ecosystem, we probably did the most to sort of, you know, explore this idea. So there was us, it was also Sunny from Osmosis who did work on that. There was other team, some teams in Korea called Everett. So there was a lot of early attempts. But if you look at it today, right, in Cosmos, actually only about 1% of the, so this is now the Cosmos Hub, right? Only about 1% of the staked value is staked through liquid staking. So this is still very small, whereas on Ethereum, it's 39%. So it's really a huge amount. And of course, so 20 out of 50 billion. Now, why is that? I think this has a lot to do with what I said before about the staking design, where on Ethereum, you know, you had no withdrawals. and you couldn't stake less than 32 ETH, so it really drove people to using liquid staking because of how the base layer staking protocol was designed. On Cosmos, really, it's very easy for anybody to stake, right? So the reason to use a liquid staking protocol is a lot less. I think the one thing that you have in Cosmos, for example, why you may want to use a liquid staking protocol is because you say, oh, I want to reuse the collateral and I earn more yield. But of course, for that, you need to have a lot of DeFi protocols. You need to actually have those yield earning opportunities, and they're still pretty scarce at the moment. So I think that's why we have not so much adoption at the moment on liquid staking here. However, I think it's pretty clear that liquid staking is a very attractive product and we continue to grow. Probably in the next bull market when there's a lot of things to do with liquid staked asset, we're also going to see it grow a lot on Cosmos. And of course, Cosmos liquid staking is pretty new. We have the two main here, Stride and Quicksilver, and they've all launched within the last like 6 months roughly. But there are some interesting questions around liquid staking. One of the questions that's being debated a lot is this a sort of winner-take-all market? Are we going to see one protocol that dominates? Because if you just have one protocol, one liquid staking asset, you can have all the liquidity around it. So that's one thing that's being discussed a lot, certainly. If you look at Ethereum, where the market has been going for quite a while, you have Lido that's like very dominant. Or can we see diversity of solutions, right? Can you see 3, 4, 5 liquid staking protocol, maybe more, that somehow all manage to thrive, which might be better from some perspective in terms of decentralization, but it might not be feasible. And then I think one thing that's also being discussed a lot on Ethereum right now, and it was discussed a lot on Cosmos in the past, is what is the impact or the kind of relationship between governance and liquid staking? So, does something like LDO become a sort of liquid stake, like a governance layer for Ethereum almost? So this is liquid staking. It's one of the most active areas, I think, at the moment in crypto. In terms of new investments, new projects, the most assets are being kind of locked in DeFi is through liquid staking. So the second one is MEV, right? So MEV, what is MEV? So MEV, again, there's like different explanations, but one way to think about it is that a user makes a transaction and then at some point it gets included and finalized in the block. And along that way it goes through different stages, and in these different stages there are opportunities to use the information or to do something, change the order, insert their own transaction, and make money that way. And of course, this has become a very prominent thing on Ethereum. That's basically the only place where MEV is really, there's significant value in MEV at the moment. But if we are going to see, crypto being widely adopted, if you're going to see mass usage, then MEV is going to be relevant on all of the chains. Actually, Cosmos is probably one of the ecosystems where, besides Ethereum, there's the most going on in MEV. And there's a lot of different approaches that are being taken in Cosmos as well. They're quite interesting. Because in Cosmos, you have a lot more control over the chain. Because you have the governance that controls a particular chain, a particular application, you can do particular things. So there's two things that come to mind. One is that you can potentially say, hey, let us try to capture the MEV as a protocol. So this is what Osmosis is doing, where they're basically having Skip as a third party write software that will capture the MEV as it happens and then kind of pay it back to Osmosis stakers. So this is one thing that's being done in Cosmos. And another thing here is that if you think of things like sandwich attacks that are sensibly negative for the users, then you could say this is damaging the chain. And on Ethereum, a validator maybe doesn't care, right? Because there's so many validators, everybody's doing it, there's no delegation. But in Cosmos, you're depending on delegation as a validator. So if people see, oh, my validator is doing something that's damaging the chain just to make some short-term profit, then they're probably going to lose delegation. So I think we haven't really seen any of this harmful extraction from validators in Cosmos. And I think actually Cosmos chains are pretty well set up for that not to happen. From a validator perspective, MEV is actually pretty interesting because it's one of the only places where you can potentially differentiate, right? Where you can generate a higher return than other validators. Because if you think of the other categories, new tokens that are being issued, that's a network parameter. You can't change it as a validator. And if you think of gas fees that the users pay, well, again, this is not something that's under your control. But MEV, you are able to have some influence there. So for example, we have been spending quite a lot of time on that on Ethereum, where we're trying to explore, okay, how can we, optimize the MEV returns? And here you can see us tracking sort of the MEV returns versus Lido, and doing things to generate better returns. But that's something that's pretty Ethereum specific at this point, and I don't think it's really happening on any other chain in a meaningful extent. And so I think when it comes to the future of MEV, it is really very, very open and very unclear. There's a lot of different things happening, a lot of new protocols that are being created on top, or also changes that are made to the fundamental base layer to sort of take into account MEV. And there's definitely a sort of fear around MEV that is it going to become something that's very centralized? It's controlled by a bunch of trading companies. They're integrated with validators, and they're sort of then starts to resemble what people are maybe seeing in the traditional finance space? Or do you see much more of a sort of open system where there's a lot of different participants and different markets, and it's maybe transparent and more sometimes it's called like democratic? But I think this is really very, very open, and especially also open in Cosmos. So we've also of course we've also been working with DYDX on exploring how MEV could best be handled for app-specific DEX like DYDX is, and there's going to be a report coming out on that, I think, in August. So two more. So restaking, I think, is another one of the topics that's been getting a lot of attention. And again, actually, Ethereum and Cosmos are probably the two ecosystems where this is the most the case. And what is it about? Basically, when you're staking, you're locking up assets, right? So they are on-chain, and they're sort of frozen there. And of course, there's a question. Let's say if you look at Cosmos, the Cosmos Hub, then only 5% of the amount that's being staked is actually slashable. So you could say 95% of the tokens that are being locked up, they're not really being used. And so the idea for, okay, but how do you address this, or how could you deal with this in a different way, a more efficient way, has also been around for a long time. And of course, on Cosmos, we now have two kind of concepts or two technologies that are trying to address this. So you have interchain security, and you have mesh security. Both trying to basically allow people to kind of stake their assets multiple times at the same time, and thus generate higher returns, but also use the assets better and provide more security. And on Ethereum, you have a project called EigenLayer, which is also basically trying to create a sort of layer on top of Ethereum where people will be able to put their liquid staking tokens like staked ETH and then use that as collateral to secure additional services that validators and node operators run. So you could imagine something like Chainlink, where basically, okay, some node operators run an Oracle service, and people put up their staked ETH as collateral to guarantee the running of their Oracle service, and they're then able to earn their ETH return from staking and some additional returns from these additional services they secure. So this is very early, right, this restaking topic, but there's no question that, in the long run, this is going to become very important, and it's going to lead to capital being used a lot more efficiently. But of course, efficiently also means that we are going to increase risks, right? Because you're basically layering different levels of risk, and of course, in the sort of worst case, you could imagine some kind of cascades of failure, where you have something breaking underneath, and then it erodes the value, and then some other protocol building on top that's relying on the same thing, all of a sudden it's no longer secured. So I think it's clear that there's risks here, but of course the big difference between the traditional financial system is that this should all be transparent and on-chain, and so we should have at least visibility into what's going on. Yeah, so that's another area. And yeah, I think we actually, Cosmos ecosystem now seeing some of the most activity here. For those who were at the Osmosis event, I think it's maybe here as well, right? Where mesh security is now being demoed, and there's some early things on that. And of course, ICS is now live with the first chains. And then final topic I want to touch on is layer 2. So layer 2, I mean, what are layer 2s, right? Layer 2s are basically blockchains that are trying to inherit the security of another blockchain. And the idea here is that you could be maybe more secure and that the security can be cheaper. So if you think of like Ethereum, right, there's a huge amount of staked value. So can you build some kind of blockchain on top of Ethereum that, leverages the security of Ethereum, but, you can scale that way, have more transactions. And of course, Ethereum had, different visions over time in terms of how to scale. And at this point, they've kind of given up the idea of scaling the base layer very much at all, and really fully betting on people building these kind of Ethereum secured blockchains on top that then provide the scalability for Ethereum. So if you think of this in the terms of staking, right, on the surface, or the sort of first side, this is a threatening thing for the staking economy, right? Because maybe you don't need staking so much anymore. But if we kind of look a little bit deeper, I think it becomes a lot less clear how this is going to interface with staking in the future. One of these is that a lot of these rollups, right, they have sequencers, or these layer 2s, they have sequencers. So they have a particular role that basically takes the transaction, orders the transactions, and puts some proof about those transactions into the layer 1. And often this is, just like one server at the moment that's doing that. And on the one hand, this can be, somewhat trustless, but on the other hand, it's also very centralized. So if you think about it, so for example, they could just turn off the server, and then no transactions are going through. So of course, this is a big challenge, not least from a regulatory perspective. Well, you could say, oh, this is not, it's just not very centralized. So I think with DRDX, actually, this is one of the main reasons why they decided, actually, we want to have a Cosmos chain instead of being a rollup, because of the centralization of layer 2s. And I think this is something that, basically everyone is aware of and people are working on. And they're trying to decentralize the sequencing. But of course, what does it look like? Now, if you decentralize the sequencing, it basically means there's like different parties that could fulfill that role of sequencing. And then you may need some sort of consensus to agree, okay, who is the party at a particular time that's doing the sequencing? And if you want to make it open so that, arbitrary parties could like kind of come in and do some of that sequencing, then maybe you need some kind of slashing or some kind of penalty. So it's very possible that kind of over time, as layer 2s are trying to decentralize, they're going to become more like layer 1s, and they're going to introduce a lot of the same things that we see in proof-of-stake networks at the moment, like consensus and some slashing. So it's kind of a little bit still quite open. First of all, how competitive are L2s going to be versus app chains? And how are L2s actually going to look like, and how different are they going to be from proof-of-stake L1s as they are trying to decentralize in the future? And I think another one is, of course, ZK rollups. Again, they bring their own properties, and they will have their own effects on this. So yeah, I think this is another big question, right? Is like, how much do L2s disrupt the kind of app chain thesis we have in Cosmos? And how do they disrupt the staking economy, and what are they going to look like in the future? And these are some of the key trends. I'm actually just at the end of my time. I think, at this point, staking economy is like one of the kind of most largest and vibrant economies in crypto. The Cosmos ecosystem has played a huge role in that. But as we've seen, there's a lot of change, right? A lot of trends that are still happening. And so I think there's no question, right, that this economy is going to look very different in the future. I think what's also the case is that from the kind of perspective of institutional investors, staking is very attractive because it's like stable, predictable, not so risky. So I think we are seeing a lot of interest that will come in as more, more of the financial world enters crypto is going to go through staking. So I think that's also a really great thing. So yeah, thanks so much.
Awesome. Thank you for that, Brian. Right, we are going to be moving straight on again with the next speaker. So I'd like you to welcome the Ecosystem Director from Regan, Sarah Baxendale, please. Let's give her a warm welcome, please. Come on. I should be able to see it. Oh, yeah, there you go. Yeah.
So how do I just make it full screen?
Yeah, roll with it.
And then how does this work? I just click. I'll just have to stand here. I'll just have to scroll. Yeah, I'll just have to scroll.
Do you want it facing that way?
Yeah.
Yeah, a bit more. Yeah. That's perfect. Awesome. Thank you. Right.
Good morning, Nebular. Woo, right? So the internet's all messed up, so I'm going to do this PDF style so that you can actually understand what I'm talking about. So first off, my name is Sarah. I'm the Director of Ecosystem for Regen Network, and today I'm going to talk to you about climate change. So climate change is real. When I was 19 years old, I went to Biloxi, Mississippi, where the Hurricane Katrina had come through. And I looked at the landscape where the waters had risen and had ripped out an entire city. My next experience with climate catastrophe was in Hurricane Sandy in Manhattan, when 11 feet of water came in and pinned down the city. It took them 9 months to pump the subways out. So this is maybe 8 feet tall. Can you imagine 20 feet of water? At Regen Network, what we're focusing on is building a climate impact stack. And our stack has 3 components. There's an application layer and an infrastructure layer. The first piece is the Regen registry. Our community is not a blockchain community. It's real-world foresters, it's farmers, it's climate scientists. And they work together to create scientific methodologies so that assets can be issued on the blockchain. These are carbon credits, these are biodiversity credits, these are water credits. And Regen Marketplace is a space in which all of our technology comes together insofar as corporate buyers, like Microsoft, can offset their carbon footprint in our marketplace. And in 2020, Microsoft offset 125,000 credits with us for their moonshot goal. Woo, right? Real climate change here, people. And so what we're also dealing with is that the infrastructure layer is custom built according to the Paris Climate Accord for global carbon accounting. What are you guys doing? How? Perfect. Okay, we'll work with it. It's fine. I don't know how to make it full screen. It's fine. We'll make it work. So on top of that, our infrastructure is neutral. We have this registry, we have this marketplace, we have this system of issuing assets. And so we've been partnering with registries from around the world to use our software. The City Forest Credits Registry is the US national standard for urban forestry protection and urban tree planting. And they use our software stack to issue their credits onto the blockchain. On top of that, our team has built a bridge for carbon an asset called Nature Carbon Ton, which is tokenized Vera credits between Polygon and Regen Network. And what this allows is for cross-chain carbon to be issued across blockchains for the very first time. It's the only carbon bridge custom-built of its type. And why this is important is because we've been bringing liquid carbon to the Cosmos ecosystem. Because it is our hope that with a fungible, IBC-compatible carbon token, that you as the developers of the ecosystem will start to think about how you can program carbon into your dApps. At the end of the day, what we're trying to accomplish is carbon credit retirement for real-world climate outcomes. We're a community of climate scientists using technology, and so blockchain is our tool for data attestation, claims verification. It's about making information more public so the quality of carbon credits in the carbon credit market can become more alliterated and more accessible across the market. On top of that, we have our own custom registry. These are climate scientists from across the world developing some of the most innovative science. And this year, there's over 2 million brand new carbon credits from 40 scientific methodologies being issued on our blockchain. On top of that, we're the team that originally brought you the Cosmos SDK as its lead maintainers. So we have our app, we have our infrastructure, we have your infrastructure, and a bridge. So as you can imagine, our team's been busy for years. I was going to show you our marketplace, but the internet sucks. So if you go to app.regen.network and you go to the projects page, you can see all of the carbon projects that have already been tokenized. Scroll through a really beautiful project page. You can purchase credits, you can trade credits, and you can retire them for carbon accounting claims. If I had the internet right now, I would have showed you the Nebular Summit profile. Every user profile is public. It has customizable names, so it's not just some random chain of letters trying to figure out whose profile it is. And we partnered with the Nebular Summit today to figure out the carbon footprint for this event, and we've offset their footprint so that they can be carbon neutral. This is important to the community that we use these tools and that we take action. Ooh. Whoa, something's happening. Oh, our demo's working. We have the internet here. Unexpected. So this is RioSim. This is a Colombian forest preservation project. It's a tokenized Vera credit that came across that bridge we built with the Interchain protocol. You can see all of the environmental outcomes on the right-hand side. And every time you go on the app, you can always see the issued, tradable, and retired credits to always see what's going on with this particular asset. You can always watch the video. You can learn more about the information of the project. This is the credit batch denom, which tells you which credit class, which project, the times, and which issuance there is. So in this demo, we're going to buy credits in a tradable form and put them first in our wallet. So you choose from one of these sell orders. There's a number of different currencies to choose from. And you're basically transferring them in a tradable form to your wallet. If it functions. Got to approve our transaction. You always get this lovely sheet that tells you what you just bought. Make sure you got the right thing. And then you can basically go to your wallet. We're sending to Seb's wallet for the event here, 1 credit. And we're going to do it in a retired state. So this is where we're taking the carbon accounting claim, and retired means that we take it out of circulation. We're changing the state of the asset from tradable to retired on chain. We're going to take a location. We're here in Paris, the home of the Paris Climate Accord. Another confirmation page. And now we're going to go to Seb's profile for the event. So we only retired 1 credit. We're going to retire more because there's more than 1 ton of carbon we're using today. But this gives you a sense of how we engage with the app and how we provide you with retirement certificates that you can export out in case you want to send it to your mom or your cousin or your company, your board, people you know. It's pretty, right? Whoops. Go back. So, oh geez, this slideshow. So we've been running a campaign with validators across the Cosmos ecosystem for the last 2 years, and it's led by the validators. And what they're doing is they're quantifying the footprints of all the protocols across the Cosmos ecosystem. And what it's allowing us to do is to identify those footprints, use community funding, purchase and retire carbon credits. So these are all of the chains we want to congratulate today that as communities have actually already taken climate action here in the ecosystem. So if you're from one of these communities, we salute you. And this gives you a good example of a profile of what it actually looks like when your community offsets. And what's lovely about this is the Evmos community, for example, has offset their carbon footprint. You can transparently see that they retired 7,975 credits from a project called Mina Dombe. And Mina Dombe is a forest preserve in Cambodia, which has some of the world's rarest elephants. So I'm going to tell you a little bit about some of our real-world projects real quick, and then we're going to shift gears. This is the King County Urban Forest Project. It's one of the urban forest credits portfolio that has been tokenized onto our blockchain. They're preserving an urban forest that's under threat of development, that they don't want to have it turned into a shopping mall. This is Monte de Nero in Argentina. This is the first of the regen registry credits. This is a soil organic carbon credit, and in the next 2 weeks, they're issuing 700,000 carbon credits. It's the first of a massive wave of credit issuance that's coming out of the regen registry. And this is ERA Brazil. ERA Brazil is an old Red Plus developer that decided to create their own methodology with our tools. And this is going to be one of the world's first biodiversity credits. What they're doing is they're looking at the habitat of the jaguar. And this is Colchian Carbon Trust, which is a biochar land trust in the state of Washington. 100% of their first issuance of credits has already been sold to a major blockchain whose name I unfortunately can't tell you right now, but you definitely know who they are. And we're just getting started, y'all. We've issued over 500,000 credits. That's worth about $3.5 million. That Cosmos Zero campaign retired over 30,000 nature carbon ton credits, the largest single issuance wave of carbon credits in all of blockchain history. And then the 2 million credits being issued on Regen Registry, our new scientific set of standards. They're going to have all these credits come out this year, and they're worth over $21 million. Next year, it's going to be about 10 times as large of issuance, y'all. So our scientific community is expanding really, really rapidly. I'm going to shift gears for the rest of the conversation very quickly and show you something really cool. We're shifting our technology, and it's in governance right now, to be able to have a permissionless experience for credit issuance. What that means is that any community garden or a local community project will be able to use the tools that we use internally for yourselves. This is available already on testnet, dev.app.regen.network, so you can go on there and play around with these tools yourself. So we're going to make a credit, y'all. You excited? So this is Hilltop Urban Farm. This is our use case. I'm the designer of Hilltop Urban Farm. I'm actually a landscape architect and a former city planner. So this is the U.S.'s largest urban farm. Adult farmer training program, production orchard, youth farm, community farm plots, community garden, and this necklace around my neck has some of its soil. So today we're going to issue credits very quickly for our youth farm orchard. And this is what it looks like in real life, y'all. It's absolutely massive. But more importantly, here's its people, the people that actually benefit from the work in this space. So when I'm designing my credit class, I take my orchard. I map out what kind of trees there actually are where. Got apples, plums, cherries, And then I worked with the Penn State College of Agriculture to quantify the carbon outcomes because they were the research professors that chose the climate-appropriate rootstock for this area. And so I'm doing a very simple calculation as an example of how I can count up how many credits these trees have produced from like metric tons of carbon pulled out by the trees over the last 5 years. But to get this on chain, y'all, on DevNet, I gotta make a metadata schema. Super cool. Gotta put it on CLI. And then I end up with this really beautiful page. It's basically alliterating all of the metadata that you have for a credit standard on the blockchain. And these are tools that you can use for yourself on testnet. This allows me, once I have a crediting standard, to issue a project. So here's the farm, here's the standard, and I issued the credits already. This is Miss Amy right here. So this gives you a real quick example of how you have a real place. You have real people, you're doing real things. And unlike a lot of the other projects you're going to hear from today, it's a lot of tech talk, we're a lot of people talk, and a lot of place talk. Because at the end of the day, what we're trying to accomplish is we're trying to restore ecology. An ecosystem function is the interaction of all species in a place when we leave them alone. Because the Earth and its ecosystems are a self-regulating system. It's only because of our intervention that it has become destabilized. And I fundamentally believe as a human that we have a deep responsibility to take action. And so I've spent 15 years of my life building places that are restoring themselves because of the way that they are inherently designed. And I've spent the last 4 years at Regen Network trying to build a software stack so that anybody that builds a place like I build at Hilltop Urban Farm has the technical tools to engage with the market. And if you think about it at a fundamental level, this is a community project in a neighborhood that was distressed. It's a top 5 food desert in the city of Pittsburgh. This has quadrupled the amount of food grown in that city by one site. It's the single largest location to affect that city's climate action plan. And they should be able to issue credits for themselves. They should be able to design those credits because they designed that space. They work with their communities and they implement real-world land regeneration. This is the most important thing any of us are ever going to do. And so we really need to take a look at who we are as a community and invest into systems and tools that directly affect climate change. I believe we have both a moral obligation and a huge opportunity here. And so if you understand a lot of what's available, right now in osmosis, there's all this liquid carbon, hundreds of thousands of tons. This community can program that into its dApps. We can come up with retirement aggregators. There's so many tools that we can alliterate off of this fundamental architecture now that we have done it. And I believe that if we don't do something soon, this is really going to get away from us. And ultimately, this is a room filled with people. Some of you have children, you have families, and it's only going to get worse if we don't do something. And so we're at a point where we're trying to make our tools more available to everyone, behave more permissionlessly, behave more ETH-like, give people the tools on a very small-scale basis, one little farm, one little city, one little town, that you can basically communicate what you are planting in the ground and how you want to approach it for yourselves. So as an ecologist and as a technologist, I really believe that we have to change our way of being. And all I really want from this community is for y'all to join us. Because the rails are there, the stack is there, and there's an enormous number of projects issuing credits this year. At the end of the day, if we don't do something, it's going to affect all of us. And that's why we keep building at Regen Network, where we're building origination software, where we're bringing all of these projects into the pipeline from across the world. And so it's my honor and my privilege to create in this community of people who actually care about real-world change. the experience that people have in communities and the experience that's happening on the ground. So thank you for listening. Have a nice day.
No, that was great. Thank you, Sarah, for that chat. We will be moving on. We will be having a lunch break after this chat, but I think Seb's going to come and have a little word about something as well. So we'll just hold fire for 2 minutes. But I would like to introduce the next speaker, the CTO and co-founder of Injective Labs, Albert John. Oh no, you need to take that.
No, I don't need to come out. I just need to click it.
You're just speaking. You don't want to have the...
I sent it already, PDF. Yeah. Just my notes.
Yeah. No, that's fine. Right, let's give him a nice warm welcome then, please. Albert John from Injective Labs.
Hello, everyone. My name is Albert Chon. I'm the co-founder and CTO of Injective Labs. And today I'll be talking about the app chain revolution, redefining DeFi through cross-chain integrations. Is this working? Oh, sorry, wrong clicker. So Injective is a blockchain built for finance. Our focus is on powering the next generation of DeFi applications and providing powerful, advanced DeFi infrastructure and primitives for builders. All right. Yeah. So first, I'll talk a little bit about the Injective ecosystem. The Injective ecosystem is one of the fastest-growing ecosystems in all of Cosmos, with numerous DeFi applications and integrations building on top of Injective. And I'll speak a little bit about interoperability. So interoperability is at our core. Injective connects with numerous blockchains through IBC, through with Axelar and Wormhole, and even our own native Ethereum bridge. But for us, interoperability extends beyond just blockchain bridging, but also within the chain itself. And most importantly, compared to other limit order book DEX protocols, the order book on Injective is fully composable with smart contracts in CosmWasm. Now, CosmWasm is a great framework and it has native compatibility with Injective. But we found that for new developers, the learning curve for onboarding CosmWasm, even if they already know Rust, is quite high. There are many concepts specific to Cosmos and CosmWasm that you have to learn. And as we spoke to many developers, especially those coming from Solana, we heard these criticisms and difficulties for them to even deploy their basic application. Basically, they'd have to not only rewrite their application code, but have to learn all these new concepts and security guarantees. So we took these considerations to heart and tried to build a solution for them that they could use. And my clicker is still not working. And that is Cascade, which is the first Interchain Solana SVM rollup. So with Cascade, developers from Solana can utilize all of the benefits of the SVM and create applications that leverage IBC and cross-chain interoperability, which I'll explain in more depth. So first, I'll speak a bit about integrating rollups from an app chain's perspective. So first, why should we integrate a rollup, particularly an SVM rollup, and why does this make sense for Injective? The first is that it provides a diverse programming environment, and it lowers the barrier for entry for developers coming from the SVM or even the EVM world with EVM rollups on Injective. And second, horizontal and vertical scalability. So on the horizontal scalability side, you can shard your execution essentially between different execution environments. One is, of course, the SVM. The other is the native injective layer. And on the vertical scalability side, the SVM, of course, is renowned for its multi-threaded runtime and offers parallel transaction processing, which is very powerful for scaling modern applications. And the final, but I would say most difficult piece is on interoperability, making essentially these SVM contracts be able to compose with injective through IBC. And currently with rollups, you have a 7-day fraud-proof window, which makes it very hard to compose in a vanilla implementation. And of course, modern DeFi applications require fast finality. You don't want to, place an order for a trade, wait 7 days before it gets filled, right? That's simply ridiculous. So how can we do this? I can summarize the current approaches to cross-chain interoperability. As I mentioned, for optimistic rollups, you have a fraud-proof dispute period that you must wait for, which results in terrible UX. There are also solutions that use what are called committee-based interoperability, and these include Wormhole, Axelar, Hyperlane, and I would also categorize these as not ideal. They embed a security assumption in the validator set, and while they are useful for applications that wants to take advantage or adhere to that security assumption, I would not use them as the foundational model for, let's say, the rollup. There, of course, is also ZK and validity proofs, which, for example, ZK rollups or ZK proof of consensus by 16 Labs are developing. But these also have pitfalls of mainly slow proof generation and just the general challenge of creating a circuit that is arbitrary and generalizable. There is some interesting work with ZK IBC, which Jack Zampolin and I believe another team is working on that deserves some note that's still in development, though. And finally, there are escrow-based approaches. For example, Dimension's escrow IBC or eIBC, which essentially uses a market maker or some liquidity provider to take on the risk of having these tokens be bridged over, or basically vouchers, and purchasing or giving the tokens out on the other chain. And this approach, while it's more of a band-aid solution, it's limited and it incurs extra fees. So the next approach that Injective is exploring and wants to take is called essentially a consensus rollup. And let me see if I can get the next slide. Thanks. And the idea here is that how can we bypass the fraud-proof window of optimistic rollups, since this is a major impediment towards IBC interoperability. And the idea here is injective validators will run a rollup full node and attest to the rollup headers on the blocks on injective. So the mental model analogy you can use is, suppose you have a ZK rollup, but you replace the ZK proving system with just the validator signatures, and you essentially get the same security guarantee. And what's different here is that because it's an L2 of an L1 with a fixed validators, or not fixed, but a smaller validator set, you're not making any incrementally worse security assumptions than you were already making. And that's also why Ethereum would never do this, because you could never get Ethereum to sign off on their entire validator set to have to be burdened with this requirement. And just to go over the mechanism a little bit in more depth, the validators continuously track new headers of the rollup, attest to them on injective, the mechanism of which can be done as implementation detail using vote extensions, which are nice because they allow you to do this in process, or just with normal transactions from the validator. And once 2/3 of these validators have attested to the correct header, the header is committed to the state on injective. And now, because it's on the state of injective, the header can be proven using a light client, and the IBC packet inclusion can run as normal because, and this allows for you to have IBC connectivity with a rollup. I'm also very excited to announce the partnership with Espresso Systems on bringing decentralized sequencers to injective. So Espresso Systems has, I would say, the most state-of-the-art technology in the rollup sequencer space. And our overall goal is to work towards atomic composability. For Espresso's decentralized sequencer, for its shared sequencer, actually, you can have fast finality with secure transaction ordering and strong data availability guarantees. What's interesting is that in a rollup to rollup setting, so in the scenario where you have multiple rollups on injective, you can have atomic cross rollup transactions. And this allows for, in some cases, cryptographically guaranteed cross rollup transaction bundles, and in other cases, crypto-economically assured cross rollup bundles. And that's using a block builder with proposer-builder separation. And the final boss to conquer, I would say, would be shared sequencing or atomic composability between injective, layer 1, and a rollup. And there's an open question about how this can be done. It's actually unsolved. And whether it's even feasible to have shared sequencing with the sovereign L1. There are some ideas based off heterogeneous Paxos, and some other ideas like perhaps we can bring PBS to Tendermint and use ABCI++, prepare and process proposal for this. Or maybe we can even not aim for atomic composability, but have a more best effort or optimistic atomicity. These are questions that we are now pondering in this design space to, of course, eventually improve the UX for cross-chain interoperability. And taking a step back, I'd like to remark on the power of self-sovereign, interoperable, application-specific blockchains. Some of the design choices or things within our consideration would never be possible on layer 1 Ethereum, right? The concept of having validators do work for, let's say, attesting to rollup headers, that would never be acceptable in Ethereum, not to mention the slow pace of movement of development and the ossification of standards. And this is the sort of thing I guess I would like you guys to take away about when you build with an application-specific blockchain, you have a lot more freedom on every layer of the stack, from the application layer to consensus to networking and all these other requirements that you may want to impose. And it's become a lot easier to do with ABCI++. So that's it. Thanks for listening. You can follow us on Injective on Twitter, and yeah.
Awesome, thanks for that chat, Albert. Right, we are now going to have a lunch break, so lunch will be till 2 o'clock. Go and fill your tummies, and I will see you back here in an hour. Thank you, everyone.
How's everybody doing? Is everybody having a good time? I hope you're all enjoying Nebular. I hope you had a good lunch. I hope you got your merch, checked out the venue. How's everybody love the venue? Does everybody love the venue? Apologies for those technical issues this morning. We're getting them sorted out. Hopefully the Wi-Fi will come back to life, but we're here for great content. That's what matters. And we've got lots of great content for you this afternoon as well. I want to mention a few things. You may have noticed there's a guy painting outside, right? You also may have noticed that it is the art of the T-shirts. So Cédric did the art on the T-shirts, and I'm really I love the T-shirts. I hope you like them too. And you also will notice that we have QR codes to claim different badges for today. So Creds has the verifiable credentials that proves you were at Nebular Summit, and that you can add to your list of verifiable credentials. And we also have a Stargaze badge that is the artwork of today's conference. By claiming this badge, you are part of the Nebular community, and this will give you access to some cool perks in the future, maybe some discounts on future events, etc. So be sure to claim your badge. Go say hi to Cédric, the artist, and we're going to have some other interesting things we're going to be doing with this art. So we're going to be auctioning off a unique NFT, a one issue NFT of the real life art that's being done outside. And the art, actually the physical art is going to be destroyed. And that unique NFT will be auctioned and will give the owner of this NFT lifetime access to Nebular. And the proceeds will go to a diabetes charity that Cédric really likes. So we'll be doing that tomorrow. Everybody will get an email. If you want to get access to that, you can bid on this NFT on Stargaze, and we'll give you lifetime access to Nebular. So you get to come for free for life. Yeah, final thing, ice cream is also setting up outside. If you want to get some ice cream this afternoon, please feel free. And I'm going to give it up to Danny, who's just like killing it today, man.
I need the mic.
There you go.
It would help if you gave me the mic back, wouldn't it? Just to mention, actually, the next speakers, Hyperlane, have sponsored the ice cream downstairs, so make sure you go down and get yourself an ice cream. And now I'd like to introduce the next speaker, which is John Cole, the CEO of Hyperlane. If you'd like to come and join me and crack on with your presentation. Take this one here. And then, do you need a quick up? Yeah. Awesome.
All right. Thanks for having me. So I have a talk. I got some slides. Also had a script for it, but we're going to go a little bit off script today because I feel like it. I was thinking about it last night, and I said, you know what? I'm going a little off script. So if you're here, you're probably a cosmonaut, and you got to give yourself a little bit of credit because you were right. Cosmos app chain thesis was right. It's been right for years, and now it's manifesting outside of the cosmos. Everyone's talking about rollups. Everyone is finding a way to make creating your own chain increasingly easier. We're going to talk a lot about this today. Outside of the cosmos, we call them modular blockchains. Inside the cosmos, we call them app chains. But you were right, and you should feel pretty good about it. So today we're going to talk about these modular blockchains. We're going to talk about why I believe, and I assume many of you do, that they are the best solution that we've found so far to the scalability issues that blockchains face in general. But they introduce another issue, and that issue is the need to connect between these chains, especially as it contains the crossing between different instruction sets, different virtual machines. And I'm going to tell you about why I believe that permissionless interoperability is the missing piece to making modular blockchains really, really work. So let's get into it. So at Hyperlane, we like to talk about this thing, the Interchain highway. What is that? It's a strange term. But we like to think of how can we create a safe, easy, and fast path between this increasing number of modular chains that are populating this universe. The way we do that is by introducing permissionless interoperability and this notion of modular security. So these terms might not mean a lot today, but hopefully by the time we're done, it'll make a lot more sense. So in our world, we have these internet computers. They're very cool. Starting with Bitcoin, onwards to Ethereum, Cosmos, we have an increasing number of these internet computers. And a lot of the cool things they let us do, I would argue, is mostly due to the fact that they introduce for the first time scarcity into the digital domain. And this introduction of scarcity gives us everything from sovereign money and permissionless access to computation. But with this comes a big issue. As we introduce scarcity, we're now competing for scarce resources in a way. So I really love this visualization. I don't know if any of you have seen it before, but it's one of my favorites. We got Bitcoin and Ethereum blocks visualized as buses, and transactions of different sizes visualized as these little South Parky looking characters. I think this does a great job of illustrating what digital scarcity really means for us. You want to get on the bus. Well, there's only so many seats. There's a certain block size. In the case of the bus, there might not be enough seats for you and you have to catch the next one. In the case of blocks, there's surge pricing. And what does surge pricing mean? So like, why are you here today? You're here because you care about crypto, you care about blockchains. And all of us are working to increase the demand for these blockchains. But we just talked about digital scarcity. So if we do that, what's that going to actually mean? We're going to compete for them, and we're going to run into these issues. Everyone here has probably at some point felt that the gas was too damn high. So modular blockchains and the app chain thesis as it's being materialized today are what I think are perhaps the best solution for the issues that are caused as a function of this digital scarcity. And so enter Hyperlane. We're going to cover it in more depth today, but for now, all you need to know, Hyperlane is a permissionless interoperability layer. And the only important thing to take away from it is it's a tool that we're building to let anyone connect any chain. And any chain is the really important part here. We want to allow you to be able to cross between different VMs, between different instruction sets fairly easily. You should be able to connect EVM chains with different Cosmos app chains, with Solana-like chains. Right now we're seeing people creating SVM, C-level based rollups. Fuel is going to be released sometime in the next few months. And that introduces another instruction set. So Hyperlane is how we hope to allow anyone to do that. And we're coming to Cosmos. So in the next couple of months, Hyperlane will be implemented as a Cosmos SDK module, thanks to the amazing work of the Strangelove team. And it'll be implemented as a CosmWasm implementation, thanks to the great work of the Mitosis team. If you happened to be at Modular Summit the other day, you may have caught Sunny from Osmosis talking about their interest in using Hyperlane to connect with rollups. So come into the Cosmos soon. So I mentioned to you that I think that permissionless interoperability is required to make sense of the modular stack. I think of it as the final layer in the stack, the one that completes it. Because if now we are seeing more and more tools like the OP stack, like Celestia, then roll-up service providers such as Caldera and Eclipse and AltLayer, all of them are making it increasingly easier to create your own roll-up, your own app chain. And as you do so, you need a way to connect them. And what we're seeing also is a proliferation of these different instruction sets between these different forms of chains. And so having an ability to connect them without depending on anyone else, being able to do it in a completely sovereign way and putting your own destiny into your hands is imperative. And that's where Hyperlane comes in. But why isn't this the case today? Why is it that outside of IBC, pretty much every form of interoperability, especially ones that pertain to generalized message passing, they're all permissioned? You always have to ask someone to add you, to support your chain, to support your environment. Why is that? I would argue that it's primarily because of the fact that interoperability today, especially in the form of generalized message passing, takes the form of tightly coupling the messaging interface on one hand, right? This is the product. This is what you're coming for when you're using such an interoperability protocol. And it tightly couples it with the security model. It doesn't have to be this way. It's not written anywhere that this is the way that it has to be, but for some reason, it just is. So with Hyperlane, we believe that modular chains deserve modular security. Seems like an abstract concept. Let me try and make it a little bit more vivid. Everyone here probably has a bank account. I have one too. Maybe I shouldn't, but I do. And when I try to withdraw a small sum, say $50 from my bank account, I just need a PIN. I can use the machine. I don't have to do any special processes for it. The security protocol for such a small transaction, enter your PIN, take out your money. But say I try to do a much more meaningful transaction. I try to wire $50,000 out. Now I get ran through a different security protocol. The bank now wants to see my identification. They want to ask my name. They want to ask who else is on the account. Do I recognize any of the past 10 transactions? Is there a recurring direct deposit on my account? They run me through a series of questions. And if you ever tried to close your bank account and withdraw all the money in the same day, they ran you through an interrogation, and you probably have a certain feeling right now as you're hearing this, because you know how difficult it is to close a bank account in the Western world nowadays. So what's the bank doing? Different security for different context of your user action. But we don't do this in crypto. We certainly don't do this when it comes to traversing between different chains. Whether you're moving $100 or $100 million, we treat you exactly the same. But when's the last time you saw a 9-figure transaction that wasn't an exploit, that wasn't a bona fide hack, right? Rarely happens. So what is revealed then, that once you introduce this ability, a lot of people are starting to think, you know what, this is sensible. Maybe we should have different security protocols for different actions. And this is something that Hyperlane brings to the fore. Normally, and I remember I said we're going to go a little bit off script, tend to go over different forms of interoperability, different flavors. But everyone here, if you're in Cosmos, you're probably very familiar with it. So we'll do this really quickly. So you have native verification. Basically, I'm just trusting both chains that I'm traversing between, and I don't introduce anything in the middle. If we could do this everywhere, we would. We can do this everywhere where we have Tendermint chains. We can do this beautifully with IBC. But you want to do it in other instruction sets. You want to do this in the EVM. Becomes very costly. And obviously, this is changing by the day through the amazing work of folks like Polymer and other teams. But today, this is still quite costly. It's quite difficult to do. So oftentimes, we have to resort to external verification. Same concept, still trusting the two chains connected, but now we have to add something in the middle. And that's our external verification. So where does this come into modular blockchains, right? We just talked about how there's going to be an increasing number of them. There's many great people that are working towards increasing the ease by which we can create our own modular blockchain. And so if all this resorts in now that I can create my own modular blockchain in less than 10 minutes, how are we going to deal with this if I only have a permission form of interoperability? Hence, modular blockchains absolutely need permissionless interoperability. Right? You can see a world where they keep proliferating, and as the number of app chains, as the number of app-specific rollups and generalized rollups continues to increase, we absolutely need a way for the users of those chains and the creators of those chains to connect with anyone at will on their rules. So these sovereign rollups need sovereign interoperability. So Hyperlane lets you do that. And on this little schematic here, we see the full life cycle of a Hyperlane message. Only a couple things to really pay attention to. Our mailbox. Simple program, sends and receives messages. It does exactly what it sounds like, because it's a mailbox. Then we have a relayer, a permissionless role. Anyone can relay the transactions that flow between any mailbox. You could relay your own. An app can choose to relay their own. A specific chain team or rollup could choose to relay their own transactions. And lastly, the most important part, our interchain security modules, right, where this notion of modular security comes to the fore. So let's run through a transaction with Hyperlane. You send something to the mailbox. In that message that you send, you specify the destination. Where is it going to? Both the chain and the contract. There might be several of them. And then you send some arbitrary bytes. It's going to be call data to initiate a function call on the destination. Maybe you want to initiate a swap. Maybe you want to borrow something, withdraw something. Maybe a mixture of those actions. This could be an asset transfer, or it could be as simple. I wouldn't recommend this, but you could just send a message to ask me how I'm doing. But I'm happy to tell you off-chain. Then, depending on the security configuration, we might have some type of observer, some type of either a staking validator, either a watchtower in an optimistic transaction. They're looking at the mailbox, and then once some conditions are achieved, they attach a digital signature to that message, attesting to what the validity of what they just saw. On the other chain, we have our security module. Think of this as logic through which some conditions that you set, like what we just talked about with the bank doing when I'm trying to make my, my large wire transfer. So a certain transaction size might route to a different security model. A certain type of action, perhaps an upgrading action, can go through a different security module. And then we have a relayer. The relayer is always looking at the mailbox. It sees your message. If it sees some signatures there, it's like, all right, great. I'm ready to send it home. And then the relayer initiates the process function on that destination mailbox. We're not done yet. That means that that transaction was included in a block on the second chain, but it still needs to pass the tests of the interchain security module. And if it does, only if it does it proceed to its destination, that final contract, the other side of your app. What happens if it failed? What if it failed the test? Well, it's still included in that block, but it never arrives at the destination. You're never impacted by that. So what does this let you do? Modular security can take many different forms. You could have economic security, where people are staking assets. They could stake any asset with Hyperlane's variant of modular security. If you're an app chain, you could leverage your existing validators and staking of your main asset to provide economic security for messages that are being sent. But what if, say, you only have $10 million of economic security and I'm trying to do a transaction for 20? That's not enough. What do we do then? So then we could route it through a different module. For those cases, we could route it through an optimistic module. In the optimistic case, we wait a certain amount of time. We wait an amount of time that you, as the implementer, configure. Maybe you want to wait 5 hours, maybe you want to wait 12, maybe you want to wait 24 or 7. It's really up to you. During that time, you and anyone else can observe that transaction, and you can ascertain, like, is this something that we should be letting through? Is this something that should arrive at my destination chain? Lastly, you could even do something as simplistic as a multisig. Maybe you just want to get started. You just want to test it out. You have a group of people that you feel are trustworthy. Maybe it's reputable businesses. Maybe it's your own team. So you can have a security module that is just a multisig-based validator scheme. So that's available as well. But the cool thing about this, not just that you can route based on the context of what users are doing, you can continuously update your security settings. Changing a security module is as simple as pointing to a new address. So today we already have external teams that are working on their own security modules. In fact, a ZK-based module is coming to Hyperlane sometime in the next couple of months, built by a totally independent team. So with Hyperlane, we envision ultimately a market of different security modules. And that type of open marketplace is something we think will help spur a lot of innovation and allow people to stay at to always be at the state of the art when it comes to security. You'll never feel as if security has passed you by, because you can always change to the latest and greatest. One way to make this more particularly vivid is through an example that runs through bridging, something that probably everyone here has experienced at one point or another. Traditionally, bridging is done through what I'd call an omnibus bridge, where all the assets from all the people go into the same place, into this nice little contract that almost ends up looking like a cute honeypot. Everything is secured in the same way, and if there's one breach in that security model, all the assets from all the people are now at risk. But in the form of modular bridging, you can utilize what in Hyperlane we've called warp routes. A warp route is individualized for an asset or group of assets, and each can have configurable security. So you can have a warp route going, say, from Ethereum into your app chain, and you can have a single warp route for USDC, but a different warp route for USDT. And then you can have different settings such that when we have a $50 million USDC transaction, let's treat it in one way. But when we have a $5,000 USDC transaction, let's treat it in another. So what else can you do with Hyperlane? You could have interchain swaps, swapping without a need for bridging by utilizing liquidity pools on both sides. You could have interchain accounts. The really cool concept of interchain accounts introduced in Cosmos is something that Hyperlane has extended beyond the Cosmos into different instruction sets. You could utilize interchain oracles. In fact, just this past week, an external contributor created a tool really, to allow anyone to bring Hyperlane to bring Chainlink feeds via Hyperlane to any new chain permissionlessly. And lastly, my favorite use case is interchain margin, but we went off script too much, so we ran out of time. I can't talk about today. What's the end game for Hyperlane? Looks like inner roll-up networking. It looks like more competitive relayer services, that security module marketplace that I've talked about. And of course, it wouldn't be a crypto conference in 2023 if we didn't talk about intents. It's obviously interchain intents. So if you have any questions, you can go to our docs. You can join our Discord at /Hyperlane. You could follow us on Twitter. Or you could reach out our teams here. We're going to be here for the next couple of days. You can always hit me up by email or on Telegram. We'd love to talk to you. Thank you very much.
Lovely. That was a nice presentation. We do need to keep moving on as quick as we can, so I would like to present the next speaker. So joining me is the VP of Engineering from Noland, Manfred Torrin. If you can come and join me on stage, wherever he is. There he is, making his way over. That you've got it next to your chin, that's great.
Is your like clicker? Yeah.
I'll probably forget it when I get back up anyway. It's a day coat. You know, it's like.
Are you full screen?
Harder, not harder.
Nearly. Is it normal? It's okay for them. Détecte rien. Je suis sur ce scène. Ouais. On va passer par ça.
check out the profile. Ah. C'est quoi le problème?
Fallait qu'il réfléchisse.
Fallait qu'il réfléchisse.
Test. Sound is good. Hi everyone. Today I will explain something we are crafting at Gnoland in the core team. So what we are building right now for the chain, what we are building for the ecosystem. And with a small focus on Cosmos SDK, because I guess many people here are actually developers on the Cosmos SDK or users of the Cosmos SDK. So first, what is GNO? GNO, name it the way you want. It's an ecosystem made for smart contracts, for timeless contract you can trust, contract you can read, transparent contract, interoperable contract. So basically, imagine a virtual big monorepo and building a new ecosystem of applications and continue developing the runtime, big application, collaborative, like a collaborative VM. It's based on a language we created, Gnolang or GnoVM, and basically it's a language based on Golang, developed in Golang, and with a lot of bridges between the two languages. We also have Gno.land, which is our first L1 using GnoVM. In the future, you can expect other blockchains to use Gnolang, but Gnoland to be the only one chain to provide specific services. It's built on Tendermint 2, a new version of the famous Tendermint core specifications, and it's designed and built for in the IBC ecosystem. So we'll connect to existing ecosystem and try to open the ecosystem even more with extensions of IBC. It's aimed for fairness, simplicity, security, scalability. The goal is to solve the scalable smart contract both for developers and users. So the language. We created the language. Actually, first question can be why. If you want to write blockchain contracts right now, you have basically an option to learn a new language like Solidity, another option to use CosmWasm or other translation of existing languages into blockchain. And we choose another option, which is to create a new language with the syntax you already know. So Golang is a new blockchain. It's a new language. It's not CosmWasm plus Go. Why we can't make Golang contract? Because it's not deterministic, it's not built for blockchains. So Golang is basically a Golang with determinism and with no ORM, no translation, no binary codec. So all the things you will have with CosmWasm, for instance, where the language is designed for many usages, including developing mobile application, web application contracts. So we remove all the translation between another word and the language to make dedicated language focus on the logic. It's interpreted, meaning that all the contracts are uploaded as source code and not as binary, meaning that it's not possible to actually not be able to audit what you want to execute. It also means that each time you upload a contract, it can be interacted with from a wallet, but it can also be imported. And it's not like making a call, like an API call between contracts as of Solidity or CosmWasm. It's about importing the contract, importing the objects, the rich type, the structures, the pointers, and everything. It's auto-merkleized, so basically it provides everything needed to write rich and secure dApps. It also provides everything you need to push IBC forward and push to the next level of inter-blockchain and inter-contract operability. Sorry. There is a built-in rendering option, meaning that you can have a dApp with a front end on the side, or you can use a built-in rendering system. So as a developer, you publish your contract, and that's all. No need to ask for AWS server or whatever. simple example of GNU code. So this is a full contract. This contract is not very useful, but just to show you that we don't have an ORM, we don't load any database, we don't ask the blockchain to allocate some state or whatever. We define a counter, we increment the counter. So here, this contract, which is complete, allows anyone to increment the counter from a wallet, from another contract. As a comparison, if you want to write similar things on Cosmos SDK, you will have many files, and just to have the simple increment, you will have to load the state, to convert the state from string to integer, and do the reverse to save the state. If you look at CosmWasm and Rust, it will be kind of similar. So a language people already know, but with needs to have specific libs just to interact with the blockchain. So here about loading the state, manipulating the state, and saving it. And if you just look at standard Go application, so basically not a Web3, just a simple program that will store something, at the end you still have to load database, file, whatever, and save it. So when you come back to GNU, it just focuses on the logic. You don't have one way of thinking about the code base and one other on how to submit it to an API or something. You have one way to visualize your code. So GNUland, the main blockchain, it is based on GNU VM, so the language and Tendermint 2. It will be the GNU hub, meaning that you can run your own chain without GNU, but we want this chain especially to contain all the base contracts with or without state. So you can maybe expect to have a username service running on GNU that you can use on any other blockchain, meaning that at some point you can have you can just here write your small application and relying on the existing social network from another chain. If you have a good implementation of what is a token or liquidity pool pattern or whatever, you can also include just a library from another GNU VM chain and just write your code on your blockchain. There will be a series of GNU VM-based chain managed by the core team, so anyone can build their GNU VM chain, but we will also provide multiple ones. This one is specific to all the source to be there for many, many years, while we will have other specialized blockchain, for instance, for higher computing needs, storage needs, or sharding. And there is a philosophy of keeping things simple, secure, reliable, so you can trust it. Basically, GNUland will be finished, it will run, but there is a plan that there is no upgrade as soon as we can. So you can rely on it and not expect it to change for whatever reason. In terms of interop, so just after the mainnet, we release the IBC driver, so we can connect GNUland to existing Cosmos chain. We want to have GNUland being a ICS consumer of the Cosmos hub, and GNUland will be an ICS producer for GNU VM-based chain. So chain running GNU VM can be secured by GNUland and can receive all the contracts developed on GNUland. We will have so specialized nodes, such as high storage, high computing, etc. And we will have sharding just to manage, to keep a blockchain small while having virtually infinite capacity. We plan to improve IBC for all the things we are doing. So right now we are working on IBC2, IBC GNU, IBCX, we don't have the name. But basically it is an implementation of a new protocol that you can call from the contract, meaning that it's not just about sending tokens, MIMO, or craft alternative things. It's about defining the structure you want from your contract. You can define a structure with pointers, with nested fields, and basically interact with other contracts on other chains, or local IBC on the same chain, while preserving all the richness of your types, the security, and everything. So it will bring permissionless IBC, where you can expect new features, new IBC features to be developed by just by developing contracts. There is there is an attempt to create a protocol so that it's not limited to GNU. This non-limitation could also just go further after Cosmos and even have GNU to Solidity, and not only GNU to CosmWasm or other contract on Cosmos. So yeah, the goal is to have IBC, which made a good job at being the cross-border payment, as claimed on the website, to something more about cross-border applications or microservices if you come from the Web 2. So we are building clients and SDKs. When we say GNU SDK, it can be many things, actually. Currently, the goal is to have clients when it's about consuming the chain. So for instance, with the JS JavaScript ecosystem, you can have a client just for the block for Tendermint 2, another one for GNU VM, understanding the contracts and how we basically manage the data, and another one which will be the GNUland client, so you can just connect to the chain with a simple library and just consume the data, interact with the contract, upload new contract, etc. Then we have the GNU SDK, which is actually the competitor of Cosmos SDK on the same goal to make app chains. So GNU SDK. GNU SDK has the same goal, but it's fully contract-centric, meaning that most of the things you will want to change in your chain could most of the time just be a decision made by the DAO, and you won't need to ask your validators to update their node. So we still have some similar, some usual updates, but we can prevent some of them. The goal was to rely on the unified transparency, because what we do with GNU VM is just to give the most transparent ecosystem you can have for contracts, both for looking at the source and the state. If you do this for the chain config, if you also have all the governance which is transparent, you can expect to give a clear vision of what is currently running at what version, with what parameter, with which logic, and what can actually have an impact on the chain. The goal is to have instant finality for governance. If a governance is approved, it can be applied directly without just allowing validators to run a new version which match a Git SHA on GitHub. And yeah, the focus of the SDK actually is to become the bridge between the contract and the chain. A contract can ask some information to the chain thanks to the API, like loading a bunker, receiving information through channels. But the goal was for the chain to be able to consume, interact, check the contract. So it addresses the chicken egg problem, because you can have the chain relying on contracts before the contracts are published. And the goal is to make it simple, so you can start with simple blockchains, and then you have the choice for, I don't know, various testnets, mainnets, or other options. Sorry, yeah, to basically decide what driver you want for your feature. And this SDK is actually just a plan right now, because we have SDK features implemented, but it's not yet generic. We want to focus on having GNUland working efficiently, and then it will become generic for everyone. So potential API of the final generic SDK could be like this. So ways from your base app, from Go, to check if a realm exists, to load it as a Go object, so that you can iterate over the state, so a slice, an object, whatever, meaning that you can just read everything without execution, so something very cheap in execution. You could maybe also call some function, so you can keep logic implemented in the contract while having a simple line in your base app. It's more expensive in terms of gas, but it can be an option. There will be a way to basically send event to a contract, so that the contract can consume the event from a queue on the next iteration, on the next call to the contract. You can also receive things sent by the contract to a queue asynchronously. You can share some objects, so that are usually Cosmos SDK modules, such as the bunker, So the chain can load the contract banker, and the contract can interact with chain bankers. And it will have a way to subscribe to what's happening. So basically create hook on transaction, contract state change, and everything. An example, so if you have a contract named r/system/config, which expose a propose, apply, and other method to a DAO, the DAO will take the decision of changing a limit or whatever. As soon as there is an apply, you will have the base app subscribing on the change and applying the change instantly. A similar need. So basically, we won't use proof of stake, but proof of contribution. And proof of contribution is using like a proof of authority mechanism, where the list of validator is decided by an authority, except that the authority is a DAO. So there will be a contract that the DAO can interact with to change the validator set. And the goal is to have the chain subscribing on the changes, so it can be applied instantly once decided. For the chain fees distribution, because with proof of contribution, the goal is not to have staking, but to distribute the rewards to contributors, validators, and maybe contract developers. The goal is to have the blockchain always sending all the gas fees to a banker of a module. So by default, everything is just sent for very cheap computing power to a banker, managed by a contract. And then you can have your contract managing the logic. So in the example, the contract is importing other contracts to get the current state of validators, to get the current DAO members. And the goal is to have the contract performing the split and sending the rewards. Another example is how we want to basically have a similar experience than with GitHub. On GitHub, you upload whatever you want in terms of package, but always inside your namespace. So the goal is to allow anyone to publish contract under the namespace, so their username, but also under the organization namespaces. So if you are a team member of an organization, you can upload contract because you match a certain rule defined by the contract. And here the blockchain is just hooking the head package, so the thing to register a new contract. And in this specific case of a GNU blockchain, not on the other GNU VM chain, there will be a check if you belong to the group or your personal namespace. And if you want to no more participate, contribute, we have an ongoing competition named Game of Friends, where the goal is to help us create Game of Friends, create a DAO, contribute, earn points. So this is an incentivized competition, but the goal is still to basically contribute, because by contributing to the chain before, during, and after the competition, you gain basically contribution points that will give you the ownership of the chain in the upcoming DAO. So feel free to try helping us and become a contributor. You can follow what we're doing on GitHub, visit the main website, and please come on and play with us at Game of Friends and become the first contributors. Thank you.
Lovely, thank you for that, Manfred. I just want to mention, before I introduce the next speaker, to remember to go and claim your CheckD credentials to prove that you've been to Modular Summit. Nebular Summit, sorry. Right, and that leads me to introduce our next speaker, who is the CEO and co-founder of CheckD, Fraser Edwards. If you'd like to come do your presentation, please. This one here. Is that one fun? That one? Try it.
Does it work?
Yeah.
Awesome, cool. Right, hi all. So, aware that it's been a long day, it's been a long week. This room is noisy as fuck, so I'll do a lot of shouting. If no one can hear me at the back, just raise a hand and I'll try and shout louder. But today we're basically going to talk about like how we at Checked and Creds are trying to eliminate scamming in Discord. Eliminate scamming across Discord and Telegram. Hopefully this will be interesting. And we're also upstairs, and as Danny kind of mentioned, we've got a load of POAPs, a load of credentials that you can claim across the days, including workshops yesterday, stuff for just attendees. And if you're hitting issues with any of those, we're upstairs. Cool. So what we're going to cover off, the problem, which is pretty self-evident, which is a huge amount of scamming across Telegram and Discord. Like, a lot of people in here will have had those messages. I'll give some examples. But also, it's just an endemic problem. If I go back. Introducing creds. So those are the QR codes that you've seen like scattered around all over the place. They'll prove you're here. I think they're going to be used for a prize draw tomorrow, so actually make sure you do it. And also used for various things in the future. How it works, obviously, interesting. And then also how we've like integrated and built this into Telegram. And also I can give references to how it works in Discord as well. And some roadmap and how to get involved. So without further ado, cool. So again, it's a problem. It's a massive problem. There's next slide is how much money disappears. But these are just a few examples of just how endemic this problem is and how impactful it is. And I think one of the things that gets lost is, like, this shapes the opinion of the outside world of crypto and Web3. The fact that there is such like high scamming, even though the same thing goes on in fiat, it just like crypto and Web3 just gets hammered for the same thing. And one of the additional things that we've seen recently is that trend is going to get worse with things like generative AI, ChatGPT, where you can generate massive amounts of content and just use that to scam people. It's always a cat and mouse game with scams. And so therefore, like, as soon as a tool is out, they start using it. So everyone in here will have a version of this somewhere in their Telegram or Discord, especially if you're running a layer one. A lot of them are like fake exchanges approaching people pretending to be like C-suite of companies, trying to get money from you. And the reality is they're crude, but they work. I know there are people in this room who have fallen to some of these scams. Not going to name who they are, but like it's proof that this is a problem and it does happen. And it's why they carry on doing it. And this then steps into like the numbers of all of this. So if you look at the sheer amount of scams, this was just reported to the US, it works out at around $1 billion a year, which is pretty chunky when you look at like even the TVL of like crypto in general. But it's just damaging. It's massively damaging. But I think the one that surprised me when I was looking through these numbers was I thought that it would be mostly like basically fake exchanges, people pretending to be C-suite. But actually, by far and away, the biggest like damage is rugs, by far. Like that's really where big sums of money disappear. And so, like one of the things that we were looking at when we were building creds out is how can we build trust while staying anon or like a worse pseudonymous? How can we make that possible? And then on the more positive side of things, the good thing with all of this is we focus very much on building for like security, privacy, like eliminating all the scamming stuff. At the same time, the exact same tech can be used for like engagement, for rewarding people, to build up positive stuff. Like every speaker who's been through today will get a credential. Every volunteer will get a credential. The people who went through the workshops yesterday will get them. And especially with the workshops, that then proves like some knowledge, some like proficiency that maybe you can turn into a career or a CV. And so you can start to move this into gamification, which, as the numbers on both the left and the right-hand side show, like it's big numbers and they make a difference in terms of like engagement, adoption, and even revenue. So as much as we built this for security, it's also entirely usable for like just driving engagement. So very proud to announce today with Nebular that we're actually announcing the release of creds. It's very much focused right now on like POAPs for attendance, but over the coming months we'll be opening this up so anyone can start issuing. So any other project, any DAO, any organization could start issuing those credentials, but also start having those integrations with Telegram and Discord where you can eliminate that scamming, protect your communities, and just stop this endemic problem that we have. And the key thing, obviously, is the tagline. So your reputation, portable, private, and secure. Cool. So let's start with the user view. So anyone who scans a QR code has probably been through this already. But ultimately, it just looks a lot like NFTs, but private. So the ability to go in, see what you're eligible for, what you can claim, and just be able to bring those into your wallet. As you can see on my right, your left, these could be anything. They could be social profiles, they could be roles. You can also get different issuers. So right now we've got ourselves, Creds, and Nebular. Like I was saying, over the next couple of months, we're going to be opening that up so anyone can do this. Anyone can get involved, anyone can issue those out. And one of the best things is you can also mix those together. So what that means is I can combine credentials from various different projects, various different roles, or various different events in any combination I choose and share them to different people. So what that means is you can just build up that reputation over time. It's not tied to a single organization. It's not tied to a single centralized authority. You can build that up from anywhere. You can choose what data comes in. So one of the examples of this is if you scan the one on my right, you'll find that it's got my speaker credential. It's also got the fact that I work for Czech, the fact that I have some knowledge. If you scan the one on my left and your right, you'll find that it's just that I'm an attendee. And if I don't share the same credential to the same people, there's no linkage. So I can just maintain complete privacy and anonymity or pseudonymity by just not sharing the same data with people. There's no correlation problem. And so compared to NFTs or SBTs, you maintain much stronger privacy. And also, this is completely customizable. So you can build up, again, any combination of these. So afterwards, if you want to come up and test that out, we can actually prove that that works, or just scan the QR codes now. So this is a creator view. So this is on the more, I guess, similar to NFT side, actually creating credentials, issuing them out, allowing people to go and collect them. And this is under development right now. So if you're interested in where we're going and want to help us out, get in touch, and we're up in the booth upstairs. We're looking for user feedback. We actually want to be able to work with people to shape it out. And I can see Ross, our product owner at the back, we'll actively work with you to go make it work for you and make it super slick. And this is how easy it is. It's basically going to be 3 steps. So first thing, just select a credential type. So this just templates out, is it a role, is it an event, is it a ticket, is it learn, or is it something that we haven't built yet? In which case, this is the point, come get in touch. Next thing, just enter some details. Pretty quick, everything's templated out, enter that content. Everything that isn't dynamic will get populated. And then the final thing is literally upload a CSV. You just need, unique identifiers or handles, the type of credential you're issuing to, and also whether you're issuing, revoking a credential, suspending a credential, or deleting it. And this is one of the key differentiators here. You can suspend someone's credential. So let's say, or revoke it. So a great example would be, I work at Checked currently. If I was to leave in the future, someone could revoke that credential. That would allow me to still prove that I worked at Checked, but not that I'm currently employed. And so that way you can actually build up a CV that's verifiable that you can take pretty much anywhere. And in the same vein, we can suspend credentials. So if there's some worry about is this person acting unethically as an ambassador, then we can suspend them for a time. And that is actually visible inside the credential that can be checked, and basically just provides another layer of protection. And so these are just a quick overview of the different types of credentials. So I left Ross's picture in rather than mine, because I thought I'd stitch him up. But you've got, if I go, my right to left, your left to right, you've got social profiles. So these will be anchored to your Telegram, your Discord, your GitHub, your Twitter. But you can share them across any channel, so you're not having to do it within the channel anymore. Roles. So are you an ambassador? Are you a team member? Are you C-suite? Are you in BD? What is your role inside that project, and what are you therefore empowered to do? Endorsements. So this is something I would love to see, is projects endorsing each other so we can get rid of people who are bad actors. If you're missing endorsements from people, and this is built up over time, you don't have the same level of reputation as someone who has got multiple people endorsing them either for a skill or delivery or just something. And finally, so tickets. So I think this is something that, obviously the guys at Omniflix have built something fantastic out of. You can have the similar use case, and then we can back them off to, let's say you want to make an event which is only accessible to people who have contributed to your project over time. That's something that all of this works with, where you can prove that you've done this consistently over time, achieved a reputation, and therefore you're eligible for tickets at a discount that maybe other people aren't. And on the flip side, so this is some of the stuff that we've maybe like actually launched out over this week. So things like POAPs, obviously very similar to NFTs, but private. You don't need to show them off if you don't want to, and then they become available. Learning credentials. So the workshops yesterday, do you want to demonstrate that you went through a tutorial, that you went through a quiz, that you went through a workshop? Is that relevant for a job that you're about to kind of go for? Achievements. Were you early into a community? Are you a whale? Do you want to be able to show that off without also doxing the address that is tied to that? That's something we're able to do. So you're able to prove that I own something within a set without actually giving away any of the details of exactly that address. And I guess the final side is what I was reiterating earlier. Is there something we're missing? Is there a credential that you want to build out? We know from some of the guys in other projects, they want to be issuing carbon credentials. They want to issue credentials to show that projects have offset their projects. Offset their carbon and their energy usage, and they want to be able to demonstrate that elsewhere. So how does this work? So, okay, this is where I can kind of get into the real more technical side of things, which obviously Nebular is about. So under the hood of creds, we're using digital credentials or verifiable credentials. So this is very along the lines of decentralized ID, self-sovereign ID. The data is under your control. It's under your ownership. And therefore, what we've essentially got is someone issuing or creating credentials, someone receiving or verifying that data, but individually, everything is under the control of the holder. So what that means is, you get that control, that privacy, and that's why we have that model where I can decide what I share and who to, in what combination, in a way that you just can't with NFTs or SPTs. And under all of this, so we mentioned at the top, we're from Checked, but the actual, sum of the application on top, we're calling creds, and the ability to, have that whole user interface and have that control. The beauty of this system is, again, all that data routes off Ledger. So what that means is super private, no one can see it unless you share it, but also the volumes and the scale that we can do are just absolutely colossal. Because we're not tied one-to-one to the Ledger, we can get huge numbers of credentials out to people in a very, very quick way that's very, very efficient. Ultimately, when that data arrives at the other end, they can check the cryptography against the ledger. And again, if anyone has any more technical questions, we're up at the booth, and Anchor from our team ran a session this morning which delved into more of the specifications, all that kind of stuff. And if that's recorded, hopefully everyone will be able to go and check that out. But the main focus of this, so this is where I want to spend probably more time than any other slide. So this is actually how we built this into Telegram. So there's a lot of text on here. I'm hoping this is recorded so we can share it afterwards. But the whole focus here is that I should be able to verify someone and who they work for and what they do without needing to leave the channel that I'm interacting with them in. So in this scenario, what we've done is blended credentials and Telegram so that we can start proving identity without leaving that channel. And ultimately, there's a load of complex steps on the left or right-hand side. But really what it boils down to is I, for example, could message anyone in the audience here. They could forward that message onto a bot that we have, and that bot in turn will ask me for a set of credentials. And if I can't present the right ones, it will give you a warning flag and say, basically, don't engage. So the whole onus here is on whoever is messaging and initiating contact and trying to kind of do the scam or initiate the relationship has to prove who they are. They have to be able to prove who they work for, what their role is, why you're interacting with them. And the whole idea here is we can just eliminate that low level, which is people just doing mass messaging, trying to catch people out, pretending they're exchanges. So the user journey on Telegram is super slick. We're in the process of rolling it out. It should be available in the next couple of weeks. And we're doing the same thing in Discord. Discord obviously is, again, a hotbed of scamming. And we really need to go and get this sorted out. So in probably a week or two, we'll be announcing that this is out. From that point onwards, anyone that our team messages, use this. Check our credentials out, make sure that it works. Challenge us, ask for the credentials that we should have. And if you're getting messaged by someone who is pretend to be us, they won't be able to fulfill this anymore. And that's the beauty of this. And obviously, like I was saying, the focus on this kind of session has been getting those credentials out the door, getting these POAPs, launching this properly. over the next month, we'll be working on issuance and actually rolling this out for any other project who wants to use this. And so again, like if anyone wants to come to us and help us shape that user journey, shape those credentials, and help protect our communities, get in touch, because that's exactly what we're here for. So I've only got 4 minutes left, so I'll go through the roadmap really quickly. And that covers off like a lot of what I've already started discussing. So obviously the biggest thing I mentioned was a creator admin dashboard. So that's for, say, your community managers. It's for anyone in BD who wants to be able to prove who they are. But also then moving down into like Telegram and Discord integration. So exactly what I just kind of explained earlier, the ability to check who someone is without needing to leave that channel at all. One of the things that the whole purpose of Checked, which has ended up in this demo, is building out payment infrastructure for decentralized ID and credentials. So what that means is the ability to, if someone issues a credential, get paid whenever that credential is used in the future. So for anyone in this room who was like wanting to issue POAPs, wanting to issue learning credentials or role credentials, we can actually set this up so that there's a recurring model where those are paid for. And that'll be built into Cred, so it's just seamless. And one of the things that's like probably reasonably immediate is gamification. So for example, how many, like, were you within the first 5 of whatever it is? Were you the first person to collect that credential? Does that give you something that is even more like niche or like constrained than someone who just has that credential in the first place? But also, how many times have you shared that? How many times have you shared that credential? And I think at some point, either me or Danny will be explaining that like sharing these credentials is going to be part, I think, of a prize draw tomorrow, hence the drive for like collecting these things, sharing them around. But then we go into like Q4 and beyond, which is like use case specific functionality, trusted creator list. So what that means with a trusted creator list is no one can impersonate you. There can't be someone who spins up like a checked copycat and manages to get through that. Similarly, the ability to have a configurable decentralized reputation. So what we mean by that is the ability for someone to say, okay, like I'm running, I don't know, a new event, and I want to set some level or some expectation of the credentials that people have who will attend, and make that completely dynamic, or it could be peer-to-peer. So what that would mean is, like maybe I need KYC because I'm a DeFi exchange or I'm a bank, one of those two. On the other hand, I might just be operating with someone peer-to-peer. I don't care anything about KYC. All I need to know is, do they own their own handle? Is that accurate? Have they been part of the DAO that I'm part of for like the long enough time? Have we like built this established trust that is usable for that interaction? And then a newsfeed, so linked to like having a profile page. Like if you're sharing things publicly, actually showing that being shared, like actually as public. And then once we're beyond this, we're into like more of the longer term stuff. So obviously a big focus on this is it's enabled for community, which obviously gets tightly closed in with like marketing and that side of things. So building out campaigns, like how are those behaving? How are the credentials you're issuing being kind of tracked? So like, how are they being collected? Are they being collected early? Like what is the revenue on certain credentials? How does that break down by type? And similar on the analytics board, like again, how are they breaking down by type? How do you filter that out? How do you know what is working and what isn't working? Do you know that you're protecting your users? Are you still vulnerable to what we were saying earlier? And then getting into things like gating, avatars, and also connecting in different data sources. So we know a lot of Cosmos projects use, for example, Zeely. And so, for example, like hooking in with Zeely or Layer 3, that kind of thing, where you can bring in your rank, your leadership, and all those kind of things, so that you can actually build that reputation up across projects and be able to share it dynamically. So, final slide, which is perfect, so I've got 50 seconds left, although I can't see Danny. So, basically, if you want to go and collect these, there's the thing on your right-hand side. So, just scan that QR code. This will prove that you basically attended this. There's QR codes dotted around all of the, basically the entire venue, which is for actually going and collecting just proof that you were an attendee. And if you want to come and like actually shape how this is going to get built out, shape out the journey, either come up to the booth or drop us a note at the partnerships email down there. And I mean, ultimately, all of this is about protecting people and engaging them. And hopefully that's something we could all kind of get behind and deliver upon. And without further ado, I'll hand you all back to Danny in the next session. And thanks for your time. All the best. It is close to
Right, we don't need this one. Yeah, just 2 and 1. Yeah, awesome. Yeah, perfect. Thank you, Fraser, for that chat. Right, now time to introduce the next panel. So we have moderating is Matthias, wherever Matthias is, just working his way up now. And then we also have Cam Benbrick, who's the growth and strategy for Imperator. And we've also got Federico Kulmar, who is the co-founder of Evmos, also joining. So if you guys can come up and start cracking on with your panel.
Aren't you missing a chair?
Yeah, unfortunately, Dev Bear is not here unless a bear does appear all of a sudden, then we will bring out another chair. Where is he?
Yeah, he's coming.
He is
should be coming.
Okay, we will bring out another chair as soon as he arrives.
There he is. I see him in the back.
Oh, yeah,
See him in
he's
the
over
back.
there.
he's coming from the back.
We got a bear coming now. There we go. Let's get the other chair out. Talking about bear markets, and we got a bear walking onto the stage.
What has happened with my life?
Let's grab this one. Well done. That's awesome. Oh, leave me hanging. Here you go. You got it for mine? You got one, yeah. Awesome. You got one? No? Lovely. Right. Good luck.
Well. Okay, hey everybody. First quick introduction. I'm Matthias. I'm one of the partners at Maven 11 and part of our venture investment team. Today we will be doing a panel on how to scale on-chain governance. To kick things off, I think it's good if we start with a quick introduction, even though most people here will know you all. So Federico.
Hi everyone, I'm Federico, founder of Evmos. I've been working in the Cosmos ecosystem since 2017, and funnily enough, I built the first user interface for governance. So I think we've come a long way today to discuss about how can we improve on-chain governance.
So, hey guys, my name is Cam. I'm taking care of business development and strategy at Imperator.co. And Imperator is a validator, mostly focused on the Cosmos ecosystem. So we are currently securing approximately 40 blockchains. A part of our team is also a core contributor at Osmosis. They've created what's called now the info website of Osmosis, and we are working closely with a bunch of different Cosmos projects like Axela, GYDX, Evmos, of course. And yeah, so this is like an overview of what Imperator is.
I'm Dev Bear, CTO, co-founder of Bearchain. Bearchain's EVM compatible.
I don't think we can hear you, Dev Bear.
Is the mic on? Oh, there we go. Perfect.
Yeah, this is better.
Hi, everyone. CTO and co-founder of Bearchain, Dev Bear. Bearchain's EVM compatible L1 built on Cosmos SDK. We replace proof of stake with what we call proof of liquidity, which aligns liquidity incentives and things between validators and users on the chain. And lastly, we built Polaris, which is an EVM equivalent framework to allow other chains to integrate EVM into their Cosmos SDK-based blockchain.
We can't hear you very well, I think, so keep the mic closer to your mouth.
I gotta go close, eh? Like this? Is that better?
Yeah, that's
perfect,
better, thanks.
Perfect.
Okay, so maybe to kick things off and set stage a little bit, what are your thoughts on on-chain governance in general? Are you in favor of it or are you opposed to it?
So usually when we talk about governance on blockchain ecosystem, there are two paradigms. One is on-chain, like the ones that are in favor in on-chain governance. Most of them are BFT chains like Cosmos. And then you have like off-chain governance solutions, discussions that are happening mostly in Bitcoin, Ethereum, etc., with the EIP's standard and proposals. Of course, I'm biased, given that I've been working in the ecosystem for a long time, but I think there's a really good solution today for working on-chain governance and how can we improve it overall with, if we think of today's governance only as a framework to start building better governance mechanisms, I think there's a lot of ways that we can improve today's governance model, specifically in Cosmos, and I'm really looking forward to discuss that today with you guys.
Yeah, so my thought on on-chain governance is like, it also depends on what ecosystem you're referring to. For example, I think that Cosmos is quite well advanced in terms of governance compared to ecosystems like Ethereum or Solana or any other chains like that. Because on Cosmos, you also have like governance at the chain level, and because you have governance at the chain level, you have stakeholders such as validators that are quite involved in terms of governance. And I think, so the thing is that we still have some issues to face. For example, if you take the example of the Cosmos Hub and you check all the validators on the Cosmos Hub, the first validator on the Cosmos Hub is Coinbase, and Coinbase is not participating at all on governance. So I would like to see also more development around, some work with centralized exchanges so that they can give the opportunity to their users to give the opportunity to vote on governance, for example.
Maybe to quickly jump in there, do you know why Coinbase is not participating at all?
Yeah, I think it's mostly because of, users from Coinbase. So I think that Coinbase doesn't want to be involved in governance because of maybe regulation, or also because they also, it's like they would vote maybe for their own interest, and maybe that can be like an issue because they have a lot of voting power. So this could be a problem. But yeah, my overview around on-chain governance is quite optimistic because I would say that you give the opportunity to your stakeholders to have an opinion about a specific proposal.
Yeah, in my opinion, one of the biggest things I think is important for on-chain governance is easy ways to express what you want to do as a piece of code. So one model that I think is really interesting is when you can express governance proposals as actual smart contracts, and building a governance framework that allows execution not only of an instruction really easily, but having a nice format for maybe writing a smart contract. So maybe there's an interface that you have to implement in order for it to be an actual proposal. I think what's cool about that is it removes a lot of the nuance and things from the actual the proposal and just text in English language, and allows you to be really expressive on exactly what actions are going to happen and what you want to do from a code perspective. So I think things like that are really interesting and can help reduce miscommunication and improve clarity.
Okay, thanks. So I think we're at the Cosmos ecosystem, obviously. A lot of Cosmos people envision a world with hundreds or thousands of app chains. How can we keep, it's also the name of the panel, on-chain governance scalable for users? I don't want to spend all my time reading proposals, etc. What's your vision here? Federico, you can go first.
My take is that not all decisions should be taken by every voter. That's why you have representative governance today. It's not democracy in the sense of one account, one vote, because that's not civil resistant. But what we should definitely do is how can we scale governance by having more representation and more delegation. I think a good framework to do this is liquid democracy. So how can we have more expertise specifically for technical topics? How can we delegate those votes from validators to more technical representatives that might be more suited for different actions? So in this case, a delegator, instead of allocating or delegating their votes to a specific validator, can delegate to another person to vote on their behalf with their voting power on a specific topic. And so that, I think, for scaling governance is really important because normal users shouldn't care about general topics, but the most important ones to which the community and the protocol itself requires overall participation. Not every single decision needs to be voted by every single account.
To quickly jump in there then, are there some sort of decisions that are more suitable for delegation and others that are you want everybody to participate in?
I think technical decisions are definitely out of the hands, and then that's when we see higher rates of voter apathy. But I think what the community really cares is the community treasury being well spent? And so they look into this. But of course, sometimes they say, I don't really care about the outcome of this proposal. So the question is how do we collectively care about the outcome for the betterment of the protocol itself? So in that case, having good representatives that can represent the different preferences of the different members of the community is really important.
I see the microphone going under the mask.
Yeah,
DevBear?
it's hard for me to signal that I want to talk. One thing that I find really interesting is because Tendermint validator sets are relatively small, 100, 150, how do we deal with the fact that at the end of the day, the validators get to decide what happens? If a bunch of users say, hey, we want to do this one thing, the validators can always just decide to fork the chain themselves. How do we think that that plays into a role with a model like you're thinking of, Federico?
Yeah, I mean, on our side, as a validator, we are on approximately 40 chains, and honestly, taking care of governance can be a pain. So what we do usually is that we have internally a monitoring system to keep track of everything what's happening, on all the different chains. But if we think about a world that will be maybe in the future 1,000 chains, it can be a real pain for validators. So they can either hire governance people, but it can be very high in terms of human resources. And I really like what Federico said, because there is Kujira, who's doing interesting work around governance. They have what they call a Senate, and the Kujira community vote for 9 people who will take care of anything related to community spend proposal. And I think we should have more innovation around governance, similar to what, for example, Kujira is doing.
To that specific point, also Optimism has a 2-camera model where you have the everyone from the community, you have the validators that are representing the interests of the communities, and then you have another sets of an assembly or a committee based that are specifically elected for different topics. And what's interesting is that both of them can be overwritten by the validators, so by the members of the community. So it's really interesting how you can and this is what's interesting from a democracy point of view. Today, when we elect our representatives, we can't just kick them out until the end of their period. With these different governance mechanisms, what you can do is you have 2 cameras where if there's a misbehavior or the representative is not voting on the different proposals, you can just kick them out. Or you can change them or select, just replace all the members of the assembly every 2 weeks or every month, etc., if there is a major issue with the governance mechanism going on. So there's more flexible models. Quadratic voting is one. Liquid democracy is another one. So that we can effectively scale governance in that way.
Cam, you also mentioned you need a lot of resources in-house. Do you think we should incentivize people to participate in governance?
Sorry, can you repeat?
Do you think we need to incentivize people to participate in governance?
No, I don't think so. I think that as you are, token holder, you're a stakeholder of the chain, and you should, if you want, participate in governance. But if you don't have maybe the expertise to decide on what you should vote on one specific governance, then delegating your power to someone else can be a good solution.
Okay, on the stakeholders and people having incentives, one good example of this, in my opinion, is MakerDAO. You have the maker holders and the people that hold DAI. Even if I hold 1 billion DAI, I have less say than one maker holder. How do you view this in the system? Validators can vote, people with tokens can delegate, but the users of the chain might not have a say. I want to throw this first to you, DevBear, since I think you at Berachain are doing some interesting work here.
Yeah, I think the biggest thing is kind of touching back to what you're saying about incentivizing governance as well, is you don't want to incentivize governance by just giving people tokens or giving them something monetary, but you want to incentivize governance by creating utility. So one of the things that we're doing on Berachain is really trying to align governance with the concept of liquidity. We think that giving people tokens is not necessarily great, but what if there was a way to make it so you're able to direct liquidity or have a liquidity as a service model, or something that makes it so that a protocol or a user building really wants to get involved with that because it has a benefit to the liquidity of their protocol's governance token, which is overall just a net good thing for the ecosystem as well, and that's a large part of why when we think about how we're constructing our validator set, our proof of liquidity, symbol resistance mechanism, et cetera, we think about how can we incentivize people to do governance in a way that is net positive to all. The more liquidity in any token on a chain, especially a chain like ours that has a stable coin built in, and we have like this routing system that allows us to have that hub and spoke model, having liquidity in any governance token is something that's net positive for the whole chain and the whole ecosystem.
You guys have any takes?
Yeah, so if we take the example of Maker, I think that DAI is like a product from Maker. For example, I have a Twitter account, I use Twitter all the time. I don't have, any power on whether we should rebrand Twitter as X or not, Similar to what, like I'm a user of Uniswap, I don't necessarily hold any Uni token, but I use the product, And I think that there is like this kind of distinction, and the incentivization here is like as you get like the power on one specific protocol, your goal is to incentivize any people, any users to use your product without necessarily like give power to those users. So yeah, this is my personal take on this.
So one major problem that I see today is that liquidity today is fragmented, and so is the tokens themselves that represent the voting power for governance. So one major problem that I see is that you have all these tokens allocated and spread across all the interchain, but then you don't use those tokens for governance. And so if you're LPing on Osmosis or you're putting your tokens on Stride for liquid staking, you effectively never use those tokens again for governance purpose, even though you're invested into the ecosystem. And so that's when I think like models like Interchain accounts or a Stride-like project but for governance could be really interesting in order to incentivize participation.
Okay, that makes sense. Maybe to pivot the conversation a little bit, since we also have a bear here. How do you view privacy and governance? Do you think voting should be private?
That's an interesting one. I think there's pros and cons to both models. I think in terms of the actual voting, the privacy aspect is really interesting. I think on one hand, giving users the ability to not display their vote is beneficial, but at the same time, transparency when it comes to the actual decisions that are being made is really important as well. I think what's interesting about the delegation model is it does allow you to be somewhat private in that sense, right? Like if I'm delegating tokens to a validator, that validator is voting on my behalf. Even though on chain you can see that I'm delegated to that validator, you can't directly attribute the individual to the decision that validator makes. So I think that's one aspect of it. I think privacy in general though is good, but it only works at that model where it's one token, one vote, or something of the similar sort, which has its own kind of variety of issues for Jico, as you mentioned.
I think that privacy can be great, when there is like the voting period. So because when there is like the voting period and you see like the vote on other people, you can be influenced by what other people are voting on. And having this maybe privacy during that specific voting period can be great. And then having more transparency once the voting period is finished to see what are the different type of votes, who's voting on what, and so on. Yeah.
Privacy today is not the biggest problem in governance. So if we take a step back, when we want privacy for voting, is because we want to abstract our result, our option that we selected, from corporations or from governments. There's maybe censorship. Given that today's governance is used mostly for on-chain in protocol, unless there's a clear reason to do that, I don't think that's the best problem to focus our attention when it comes to governance.
That makes sense. You also mentioned that a lot of users will need to have a vote on like spending of the company treasury or the project treasury, etc. How do you view that in relation to privacy? Like DAO members voting on salaries of people who are hired by the DAO or governance, whatever. That's always sensitive, and it sort of never ends extremely well, right?
Yeah, so one of the interesting models that we're shipping soon as part of the EVMOS 2.0 and EVM extensions is the fact that we have now a framework for smart contracts to utilize on-chain governance, so that you can create DAOs. For example, validators can select different, can create a DAO so that their community, their validator, their delegators can vote and have like a mini vote that they can then cast to the network. And so then you can create these different DAO frameworks that together can create collectively more participation in the protocol.
Yeah, I mean, that's a good point because, you know, as a validator, and also Imperator is quite community focused. So we have like different delegators that are just, you know, asking us questions about, okay, what do you think about that specific proposal and so on. And having this kind of maybe, you know, DAOs or something like that in which you can clearly discuss with your delegators about what specific decision and then make a decision on the proposal can be great. I know that Kepler is also doing great work around here in which you can clearly explain your decision on one specific proposal, and then you have your delegators that can also put comments on your decision, which is great.
Okay, you just mentioned Kepler. I think right now a lot of governance discussion happens on like Commonwealth and Discord, and then after that it's voted through Snapshot or through a wallet, etc. What tools do we need to scale on-chain governance further? So, I mean, I'm a venture investor. What do I need to fund to help on-chain governance move forward?
So, yeah, so right now it's a pain because the traditional way is to put, for example, a draft on like Commonwealth or let's say the Cosmos Hub forum and something like that. And we have some discussion happening there, but most of the discussion is happening elsewhere, on Twitter, on Discord, on some Telegram private chat, you know. And this is a huge problem because if you're not on one specific Telegram chat, you cannot follow what's happening. So, you know, so I would say in that specific case, we will need more centralization in which anyone can follow what's happening on one specific proposal and get all the information. Because if, you know, someone is asking a question on Discord and someone else is asking the same question on Telegram and someone else is asking the same question on like Commonwealth, it's absolutely not efficient. So I would say I don't have like the right idea, but we will need some like kind of tool that is centralizing all the information on one specific proposal or one specific governance proposal, and then yeah, people can just follow everything.
I think it's kind of difficult though, right? Like at the end of the day, it's partly human nature to want to talk about things on multiple channels, right? You know, in real world governance, right? There's no, you know, central website you can go to get all the information about a, you know, real world political election, right? So I think at some scale it does make sense to try to have that, but at the end of the day, I think removing, you know, personal Telegram chats and Discords and people talking about these things on forums, et cetera, is something that's kind of unavoidable. And I think the best thing that can be done is, you know, by increasing maybe transparency and making things more on-chain, that those discussions are limited more to educational resources and for research purposes and less for the actual decision being made on.
So the main problem that we have right now in terms of governance is that the weakest link for governance today is client integration. So at most, the number of participants is the number of users that are using Kepler. And I think one of the major advantages of being an EVM chain and what we've strived for in the past year is how can we open governance to other clients, other wallets. And so we had this integration today with Commonwealth, and we had them not only integrate in the same forum the MetaMask, also Kepler and other Cosmos-based wallets to improve the participation so that you have like the entire forum on one side and then you can just go and click vote in the same interface. And so that ease of user experience is what eventually is like going to foster like more participation, etc. How can we open governance to not only Cosmos but to other clients that are integrating with the specific protocols? And as you said, it's really not scalable at this point, given that you have every chain creating its own different set of proposals. So having a single integration, as you said, Dev, the standardization is very important to be able to have like a maximum number of locations to where to discuss this. But opening the clients to Ethereum, to Cosmos, to even other ecosystem is going to be very important to increase the participation.
Okay, thanks. So let's maybe use the tail end of the panel for some more personal questions. You're both founders, DevBear and Federico. How do you view founder participation in on-chain governance? Do you take a step back by design? Do you want your voice to be heard as much as possible?
I'm going to give my personal opinion, not representing Evmos, but I think it's important for founders to participate, but not to influence the vote output. So from my particular side, I participate in governance. As long as that's the case, I'm not influencing the result of the vote. And also, what is important to notice is that there's things that you better be abstaining. So I most of the times abstain myself, or simply not vote because of the outcome. I just delegate my tokens to the validators. But yeah, influencing is, I think, the most important thing.
Yeah, I would second that. You know, for speaking personally, I think since typically founders have a decent large share of tokens, it doesn't really make sense. I think no matter what happens, a founder always will influence it, despite them, you know, wanting to or not. You know, things that are, you know, said on those channels in Telegrams and Twitters, right? Even if they're not directly addressing the question, from learning about a way an individual thinks and just learning who they are as a person, you can kind of infer how they might vote on one thing or another. So, you know, personally, I think it's good to fully abstain from the process because of that. And, you know, typically, and if you look historically, the way that founders vote on proposals is typically the way they swing. And I think a large reason of that is when people are less educated, when people look up to a founder, you know, they love the protocol, et cetera, they don't want to go against the grain. So I think being completely out of the governance process when it comes to an individual as a founder is extremely important to prevent bias.
Yeah, so to summarize, we influence the network already a lot by being part of the core team. And so influencing also in governance is kind of like...
And how do you see the role of maybe your investors in that? Do you want them to actively participate and maybe influence the direction of the protocol?
Sorry, can you repeat?
The role of your investors or backers, etc.
I think it's important for investors to participate as they have vested interest in the protocol, specifically for key decisions. I don't see them participating necessarily on upgrading the protocol or anything that is more on the technical side, because of course they need to delegate that trust to the team and to the rest of the community. But for some key decisions, I've seen them participating.
Oh yeah, go on that.
Yeah, I think like any token holder, it's important that they're involved. Kind of speaking on kind of technical stuff as well. You know, we have investors who are quite technical, so it's, you know, they can weigh in on things when it comes to, you know, architecture decisions, tokenomics, etc. So I think like any token holder, it's good for them to be involved and can be net positive, especially since typically they are large holders.
And Ken, maybe to hear this from the validator point of view, have you at Imperator ever sort of abstained from a vote that was very controversial because you didn't want to lose delegation? Or are you sometimes taking a position that you know it might cost you something? How do you approach that?
No, so regarding the abstain vote, what we usually do is that we make a decision internally, and if we don't agree internally, and we have, let's say, half of the team that is on the no side and half of the team that is on the yes side, then we just abstain, and we ask our delegators to just override our vote to make their own decision.
Okay, that makes sense. Yeah, since we're wrapping up here, maybe further out, let's say 5 years from now. Right now, Bitcoin and Ethereum still use off-chain governance, right? Voting with your node. How do you think they will adapt on-chain governance? And how do you see the on-chain governance ecosystem then?
Yeah, so I think the biggest example that we have today of on-chain governance on Cosmos is the IBC specification. That was not on-chain in any way, and was able to become a standard because of adoption of the different chains. So standardization of chain is very important, but in 5 years, I see Cosmos implementing governance as a framework, as a base layer framework, on top of which you can create your own governance models that are specific and cater to your community or to your needs. I think that's very important so that we can build a better system and have more experimentation, which is what we want, not have something that is very constrained to voting power in a very centralized way that we have right now.
Yeah, I think on-chain governance makes a lot of sense for application layer things. For base layer things, it's really difficult because it often requires code changes to the core software. So I think in the case of Ethereum, since it is 99.9% base layer, if not 100% base layer, it's very difficult to do on-chain governance. Executing a transaction can't change the way that fees are collected or something like that.
Okay, closing words are for you.
No, I think on-chain governance is quite important when you want to get the opinion of your own stakeholders, But on-chain governance is not feasible for everything. For example, I would say my chain is getting hacked or something like that. You cannot just create, a proposal, just take the time to create a proposal, vote it, and so on. It doesn't make any sense. And for that specific cases, you have to do it off-chain.
Okay. Thanks everybody for your time today. Yeah.
Thank you.
Thank you.
Thank you, guys.
Thank you, everyone.
Thank you.
Hello. There we go. Thank you, guys. I hope everyone enjoyed the panel. Right, now moving on to our next presentation. I'd like to welcome to the stage founder and CEO of Secret Network, Guy Zakin. Would it be that one there? And then possibly this one here? Oh, I'm not sure. Make sure it's up to your chin.
Test. Yeah. Good. Hey everyone, sorry for the technical difficulties. I'm Guy. I'm the founder of Secret, if you don't know me. And if you don't know Secret, Secret is building confidential smart contracts on Cosmos. We're actually one of the first CosmWasm chains after Terra, if that's an important bit. Sorry. Cool. So I've been 10 years in the space, and I think I'm only realizing right now that privacy is such a loaded term that we actually may not want to use it as much, or at least we really got to fix that misconception. And the misconception of privacy, and I'm sure that all of you are thinking about it or have thought about it in your ventures in the blockchain space, is that when people tell you privacy in blockchains, you immediately think of private transactions. Basically, you're thinking of Zcash, Tornado Cash, protecting your data and anonymizing your transactions, And that leads you to this discussion where the regulators are saying everything needs to be compliant, we need to fix money laundering. There are people who are saying, look, we're individuals, we want to protect our own privacy. And all of that is important, but it also doesn't matter. It doesn't matter because when we think about privacy in such a narrow view, we miss out of all of the applications that privacy can unlock. And actually, I've started to more and more use this term encryption, which is actually, it's not one-to-one with privacy, like encryption enables privacy, but at the same time, people don't have that kind of, background or history with encryption as they do with privacy. But if I say privacy or encryption, I mean the same thing. Another way to illustrate this is just to show a list of use cases where it doesn't matter if you care about your data or not, but it does matter that you care about privacy because otherwise those use cases are not possible. So for example, MEV protection. Everyone talks about MEV. There's like 10 new startups about MEV pretty much every day now. MEV is a privacy problem. The problem is that when transactions enter the mempool in plain text and they're not encrypted, then everyone can see your transaction and reorder it to gain an edge on you. You're losing value, and even if you don't care about your data, you're losing value. Someone else is taking that value because your transactions are not encrypted. And at Secret, we're really trying to focus more and more on those use cases. Like on Secret Network, you can build applications that are MEV resistant, that get like randomness on chain, that do all this cool stuff, and you could have been doing that for like 3 years. However, let's face it, Secret is, it's a blip on the radar right now, right? It's like a fraction of Cosmos. It's one of the more active Cosmos chains, but even Cosmos as a whole is like, very, very small compared to everyone else in crypto, and it's very small compared to everyone else who's not using crypto. And we're basically trying to push this idea of privacy in a service, which allows other chains to just interact with Secret and gain those benefits without actually even knowing that they're building on Secret. I want to touch 2 examples, like more of a deep dive. One of them is Unstoppable Wallets. So Unstoppable Wallets, before we can explain what they are, let's explain what wallets are, which I'm sure most of you know. Wallets are private keys. Private keys, they're just a very long string of characters or a very long number that you have to protect at all costs. Again, it has private in the name. You need to keep it private. So you care about privacy, but you don't care about the privacy of your private key because you care about your data. You just don't want anyone to be able to steal your funds, or you want to protect it so you don't lose it, so you don't lose access to your funds. Now, there's obviously a problem with private keys because they are a single point of failure. You lose your key, you lose access to your funds, or someone steals it. So that's why people invented multi-sigs, which everyone knows what they are. Basically, don't have one key, but have multiple keys, and multiple people needed to actually spend those funds. And there's another way to implement multi-sig. That's basically MPC wallets. If you don't know what MPC is, it doesn't matter. Just think of them as multi-sig. They are the same thing. There are some technical differences, but they're not the important part. Now, most companies today that deploy MPC wallets, and these are big companies like Fireblocks or Coinbase now and many others, what they're essentially doing is that they are your co-signer. So if you sign a transaction, Fireblocks or Coinbase would also sign with their key, and only then can you spend your funds. Now this is already much better because if someone breaks, takes your key, well, if you lose it, it's a problem. But if someone takes your key, you don't lose access to your funds. However, that model is still kind of broken because if Fireblocks or Coinbase or any other services like that goes down, you lose availability to use your funds. And it's even more problematic because these services, they are profit-generating services, which makes sense. And they are closed source. And if you want to add a new asset type, or if you want to add a new kind of policy to their engine, or if you want to do all kinds of cool things, you're going to have to call them, your account manager, pay a lot of money and convince them that it's worth putting their dev team to actually improve those features. And kind of like in Web3, we would really want to replace like that part, not with a service provider, but with a smart contract. And this now starts to get closer to this idea of account abstraction, where you have a smart contract wallet that is managing your funds. The problem with account abstraction is that you can only use it on the same chain that you deployed. But on Secret, and that's really the idea of unstoppable wallets, is that you can have an MPC wallet where you have one key, or maybe several users have like one key each. Then the chain has another key. And now you can program that smart contract to basically do whatever you want. You want to program it to sign Ethereum transactions? That's fine. You want to program it to make sure that it's a DAO, and that DAO can't actually spend more than 10K a day? That's fine. You can do all that. Just one more note about this. This was actually a very, very hard problem to solve. I'm not going to go into the details. If you're very technical, I suggest you go and read the paper. There's some really cool use cases there. It involves a bunch of cryptography, and the goal was actually how do we do MPC wallets on-chain that are very, very fast and only take like one transaction. So again, if you're interested, go read there. It has all the details. And really, this is the key part, right? Like, I think that if you are in EthCC, everyone's talking about account abstraction. But to me, account abstraction is like A, a form of privacy as a service, but B, it is the right way to go, but it's the right way to go if we build a cross-chain interoperable account abstraction, not something where you have to deploy it for every rollup, for every chain, for every system independently. Another cool aspect, and again, I'm giving these examples because these are good examples to show you that it's not about you caring about your data. It's about where you need privacy in your day-to-day life, regardless of what you do. So another good example is VRF, so essentially randomness. All solutions for randomness today, they are off-chain. And at Secret, we basically develop what we call Secret VRF, and that is a way to generate on-chain randomness that is unpredictable and that you can use in things like NFT mints, casino gaming, poker, wherever you need unpredictability. And the point is that you could have used these, like NFTs on Secret have been using these for like 2 years, but as of 2 months ago, now you can do this on all IBCs. So it doesn't matter, like you're operating on Stargaze, you can use this for your mint, you're operating elsewhere, you can use Secret VRF for your applications. And I think this doesn't work. Skrilla, correct me, doesn't work right now, right? All right, so we were supposed to have a demo of the roulette. I actually don't like gambling, but it's a fun application to try out. It uses Secret VRF to basically show you how that's used in real life. We were supposed to have a demo. It's not working now, but if you go to the website, then you can play with it. It's a lot of fun. We usually do it at our events. But these are 2 examples of privacy as a service. But what does the future hold, right? Like so what more can we do with these? And what more can we do with these, not just on Secret, but beyond? So another way to think about it is that Secret is essentially bringing encryption to the Interchain. Now, again, it's native on Secret. If you're developing an app on Secret, you can do that you could have done that for a long time. If you're developing on Cosmos, then we've been integrating that with Cosmos on any chain in the past few months, and you can do that today. But the elephant in the room is, what about other ecosystems, right? At the end of the day, let's face it, and this is maybe not so popular, but Cosmos is probably the best tech that we have. It's where all of the cool builders are coming. It's where all of the cool ideas are coming. It's much more sophisticated because generally the entry barrier is higher. So you also get very, very capable developers, and good ideas are coming in. And eventually those ideas propagate back to the Ethereum ecosystem. But Cosmos itself needs users. It doesn't have enough users. Even Secret is like a top 5 chain in terms of activity in Cosmos is, again, a blip on the radar. Like, we got to work together as an ecosystem to bring the users or meet the users where they are. Looking at the ETH ecosystem, the Ethereum ecosystem needs privacy. Vitalik is talking about it. People are talking about it. These things are needed not just in Cosmos, but pretty much everywhere, and especially on the EVM ecosystems. And basically, we've spent quite a lot of time. Like, this is an ongoing discussion in the last 6 months. And today, we're announcing, or at least putting a statement out, that Secret is actually starting to look at how to better integrate with Ethereum. And with the stated goal of bringing more users to Secret, but bringing more users to Secret means bringing more users to Cosmos, because that's how the flow works. So we actually figured that we've already been working on phase 0 of this, let's say, integration and expansion for quite a few months. And that didn't came from us. That came from the market demand, I'd say. We've had projects that came to us and said they really need privacy for certain aspects, but they're deployed on Ethereum. They're not deployed on Secret or even in Cosmos. So for example, BitShop, they're doing a very cool, one of the most sophisticated private auction mechanisms, but they need the bids to be private. However, NFT liquidity and liquidity in general does not live in Cosmos. It lives on Ethereum. So they are deployed on Ethereum, but they actually worked with our team for many months to do the bridging correctly so that they can route all the secure auctions through Secret while still being deployed on Ethereum. And we realized like that infrastructure can actually be, we can replicate that to other use cases. Another example is what I told you about. So I told you about unstoppable wallets. I told you this is basically the basis of cross-chain account abstraction. Well, we actually already have like at least 2 teams that's been operating somewhat in stealth on these, like OB and Prime Vault. And actually, there's a few others that I can't share right now. And there's already quite a few companies building on Ethereum that are coming to us. And again, I can't say their names yet, but are actually already building towards that. Now, looking ahead, what we're looking for really at phase 1 and beyond is, OK, how can we systemize that? And that's kind of like what we're doing today. We're starting by adding XLR general message passing bridge in our next upgrade. This is going to still happen this year. And that way you can basically systemize this idea of routing from Ethereum to Secret to do like a private oracle, if you will, and then back to an Ethereum contract. That will be phase 1 coming this year, and we're exploring other bridging solutions. By the way, if you're operating on a general message passing bridge, come talk to us. This is relevant to us. And then phase 2, which I think phase 2 is where it takes longer, but that's actually where we want to get to. Phase 2 and beyond is about creating a seamless experience for developers and users. And I've had a lot of conversations in the last week with founders in Cosmos, with founders on Ethereum, and all of them are saying the same thing. At the end of the day, Cosmos, people are going to use Cosmos, but they're not necessarily going to feel that they're using Cosmos. And that is the right approach to take, and that is the right mindset that we want to go into the next phases beyond phase 1. So we have a booth up there where we can talk more and we can share a lot of stuff. Feel free to follow Secret or myself and talk to us. We're very excited about this thing. We're very excited about this expanding roadmap. And hopefully you are too, especially if you're builders. We're very excited to talk. Thank you very much.
Awesome. Thank you for that presentation, Guy. Right, now moving on to the next presentation of the day. If I can welcome up the founder and CEO of Lagrange Labs, Ismail HR. Did you send them PFP and all that already? PFP? To do the slides?
Yes, I do. They're also only my laptop.
Oh, there you go.
Perfect. So what's the next one? All right.
Yeah. Good afternoon, everyone. My name is Ismail. I'm the founder of Lagrange Labs. So today we're going to talk about a new interoperability primitive, zero-knowledge data parallel computation. So before you roll your eyes and expect another talk about how ZK interop works, let me stop for a moment and say the space of interoperability is far larger than we give it credit for. In particular, we typically think about zero knowledge in the context of how do we make interoperability more secure. In reality, there are a lot more uses of zero knowledge and interoperability besides that simple question. In particular, there is the question of how do we make interoperability more expressive? How do we take an assertion of state that is moved between chains and do more with it? So, let's start with a hopefully not controversial statement. State machines require state. Yet, when we think about increasing the expressivity of what we can do with a state machine, we typically think of enhancing the execution environments, about having new types of front-end languages supported, new types of state transitions supported, and we don't often think that state transitions and state machines are fundamentally constrained by the state that they have access to at the point of a transaction. So let's take a step back. What is state? You can think of the state of a blockchain as the store of all contract values, all variables, everything encoded at a point in time in a given block header. Given that these are blockchains, the state of one block is inextricably linked to the state of the previous block. So from a given block, you can really figure out cryptographically what any contract value was at any point in time on any blockchain from a single block header of that chain. Now, how does this work with cross-application state access? In the monolithic context, we typically have a single execution environment, right? The virtual machine of that chain. If you're on Ethereum, that's the Ethereum execution environment. If you're on a rollup, that's the rollups execution environment. And if you're on a Cosmos chain, that is whatever the execution environment of that Cosmos chain is. All storage is in the same tree. If you're in Ethereum, that's the MPT tree. If you're in Cosmos, it's the IAVL tree. But everything is in the same data structure and the same block header. Access is therefore simple. You're basically having all your data co-located in the same place. Now, what about the cross-chain context? Where is data? Intuitively, if you have a separate execution environment and a separate block header and a separate block time, data is not co-located. It is fragmented across a series of different locations, a series of different execution environments, and the only way to access that is with cross-chain protocols. Fundamentally asynchronous, messaging and bridging. Now, what about IBC? IBC is a tremendously effective standard for trust-minimized messaging and state queries. In its current form, it supports messaging and querying of different contract states across compatible chains. But what about historical data? What about compute or building applications that span longitudinally? For example, if I am on Osmosis, or sorry, if I'm deploying a new chain and I want to compute the volatility of an asset pair in Osmosis, it's an options protocol, and so I want to do Black-Scholes, so I need volatility. Well, how do I do that? How would I use IBC to be able to compute the volatility of an asset pair for the last 5,000 blocks, 10,000 blocks? The really only way to do that would be to send messages back and forth from every single block between two chains, or query every single block between two chains to try to figure out and derive the correct data. So in reality, this is not a very effective paradigm because you would require a near total synchronization of two chains to access that longitudinal data. And what's more likely, and this is what developers do today, is they rely on an off-chain oracle. So you have a chain-to-chain problem with interoperability, where functionally you can solve that with better tooling on top of the existing infrastructure. The issue is not security. The issue is expressivity. How, with this secure connection I have between my app chain and Osmosis, how can I derive the relevant data without requiring an off-chain dependency? And this is the environment that we exist in today when developing applications. You have what is fundamentally a data lake of on-chain state. State is fragmented across thousands of potentially modular rollups, application-specific chains, and differential execution environments. Blocks, version data structures can be thought of as a table in that database or a single snapshot of that database. And the majority of that data is not available to applications at the point of execution. You can't query it, you can't search it, you can't compute across it. You're constrained by what you can do. And so to summarize, if I want to know very specific properties of a chain at a certain point in time, I can do that. That's what these state machines are great at. So who owns NFT X in contract Y? Easy. What is the price of Juno to USDT on Osmosis at block N? Easy. But when I want to now do things that are more expressive, what is the price of Juno to UST over the last N blocks when factoring out outliers? What is the volatility of Juno to UST on Osmosis summed up with the volatility of Juno to UST on JunoSwap over the past N blocks? This is where existing technology is unable to address these questions. And so this is where we get to what our team at Lagrange Labs builds. So what we build is a proprietary proof construction called ZK MapReduce, which allows us to compute large-scale batch proofs of contract state concurrently with dynamic data parallel computation. So that's a mouthful, but what this allows you to do is to derive the on-chain properties that are intrinsic to your application trustlessly without incurring additional off-chain dependencies. By doing all of this in zero knowledge and then verifying that on-chain with respect to a secure block header source. And what is a secure block header source? Well, a secure block header source can be derived from IBC, it can be derived from a messaging protocol, it can be derived from a bridging protocol, it can be derived from wherever you trust in terms of your application. And now you can have this type of dynamic and expressive computation that inherits directly from that predefined point of trust. So in practice, this lets you treat on-chain data like a data lake, like it's in your Web 2 database. You can compute across it, you can query it, you can run SQL on it, and you can verify the result of that back on-chain using IBC, using any existing cross-chain framework that you trust. So these proofs, as I mentioned, are transport layer agnostic. So if you want to use IBC or a third-party protocol, maybe an Axelar, a Hyperlane, a Polyhedra, layer 0, we're unopinionated on that. If you trust it with your application as a developer, that's great. These proofs can be verified with respect to that predefined point of security, which means you can take that block header, you can take that assertion of state, and you can now do more with it. You can, for example, determine the users of a DAO who have voted over a predefined period of time verifiably so you can issue rewards to them. Or you can have a derivatives protocol, and you can compute across that protocol with so you can compute across the options. So you can have an options protocol, and you can compute across the DEX that you want to use to derive volatility verifiably. And you don't have to now incur an additional application level dependency on an off-chain data feed. You can basically use the existing application logic you have today, the things that are inbuilt with the Cosmos SDK or with IBC, and you can now do more with that underlying connection, underlying data. So how is this possible, and why is this possible? And this comes down to an innovation in applied cryptography that our team has been able to unlock. And what this is updatable zero-knowledge proofs. We've typically discussed zero-knowledge proofs in the context of these difficult-to-compute, highly resource-intensive proofs of the execution of some code over some predefined data set. But in reality, once you generate a proof, there are components of it that you can reuse between subsequent executions of that underlying computation. And so that means you can take computation that was used to derive a proof on an overlapping or non-overlapping data set and compose that back together to create something new. And what this means is on the marginal run, we can substantially reduce the time it takes to generate a new proof. So if you want to do volatility over block n to n plus k, and then now you want to do it from n plus 1 to n plus k plus 1, you can do so without incurring an entire rerun of the overall proof generation. So you can have very, very fast updates of your proofs and computation of your proofs without requiring incredible amounts of duplicate computation. And so what this does is it lets you minimize proving time and scale your computation through proof composition rather than through using incredible amounts of computation on the arbitrary run. And so this allows you to have these low overhead, highly expressive data connections between chains that make your application far better in terms of its access to data. And so for more information on how this works and on our team's breakthrough with this primitive, we'll be giving a talk at SBC later this year in August that outlines the full details of this construction. So expect also a testnet launch around this point as well for certain early supported use cases that we think are going to have rather large and far-reaching effects, both in the modular context, the Cosmos context, as well as the EVM first context. So thank you, everybody.
Awesome. Thank you, Ismail, for that presentation. Right, now to announce the next speaker, who is the CEO of Agoric, Dean Dribble. Let's give him a warm welcome, please.
Say when. Can everybody hear me? Because I can hear you. All right, everyone stand up. Come on. If you're a programmer, stand up. OK, so I am Dean Tribble. I am CEO of Agoric. And I'm pretty sure you can all hear me. I'm here to talk about a lot of things, including general purpose applications in JavaScript. And I have a button? Yes. So what Agoric is built, not now building, but what Agoric has built is a platform for building general purpose applications on blockchain written in JavaScript. The native programming language is not EVM, it's not WASM, it's not anything. It's the #1 programming language on the planet, JavaScript. So you can use your existing knowledge, you can use your existing tools, but more important than that, it has a JavaScript framework. It has a library like React or like Vue, like the best practice for building large applications and interesting applications is to be able to use components that other people built and put them together into a rich and sophisticated application for your users. And so it has that kind of framework, but instead of being about mouse clicks and rendering, it is about pricing and price comparison and escrow and exchange and all the things you want for blockchain applications. So why JavaScript? Right? Okay, so this is from Electric Capital's 2023 study of developer ecosystem. And you can see we have Polkadot that claims 1900, and you never know, these numbers are approximate. We've got the Cosmos ecosystem, of which there's more than 1,700 people here. No, there's about the right number. But these are daily active or monthly active developers. And then we've got a few smaller developer ecosystems like Solana. And then there's Ethereum squatting on 6,000 monthly active developers. Ethereum has been around for a long time, and it's still 6,000 monthly active developers. And we might be afraid of that for Cosmos applications, but let's put it in context. That's crypto. These circles are to scale. That is a 9-inch circle going off the screen, right? Or, well, it was on the size of my computer. So we are still at the beginning of getting developers, and what we need to get developers is to meet them where they're at, and where they're at is JavaScript. Where they're at is VS Code. Where they're at is automated tooling and CI and all of the standard that mainstream developers expect every time they're building an application. So that's where we're focused. And that's what we bring to the table, because we're going to bridge and reach out to those people and get them into the Cosmoverse, the Interchain, the Cryptoverse. Okay, and how are we doing for that? June was amazing. We have been working for 5 years on this stuff, and it was sort of at the end of June that we realized we had really crossed this incredibly important threshold. So we deployed the general purpose platform with independently upgradable JavaScript smart contracts, all communicating with each other asynchronously, where you could have independent governance for each of these things, and where very different than the rest of blockchain, right? In the rest of blockchain, your applications are built in, 5-second chunks or simple transactions, right? If you think about an AMM, it's awesome. There's a lot of money in AMMs, but the transaction is simple, right? Money come in, do some math, money go out, right? Adjust 2 numbers, you're done. That's your AMM. Yeah, you can be a little fancier than that, but it's this very discrete thing. Most software in the world has long-running transactions that are not 5 seconds at a time, but might be 5 days or 5 months or even 5 minutes. Makes a complexity in CosmWasm, in Ethereum, in all of these infrastructures where you do, your 5 seconds of computation, and then you pack it all up and store it in the Merkle tree, and then maybe, hopefully, sometime someone outside the chain says, could you make some more progress on that? So you unpack it, and you do a little more work, and then you pack it back up, and it's a lot of complexity. We've talked to a couple of people out there about what it takes to do that, and it's very complicated to do that in CosmWasm, in Ethereum, EVM, Solana, all of these systems. In our system, you have a JavaScript program that just runs, and I'll show you some of those later. But what we've done is we've packed into state sync in Cosmos, where you can take the Merkle tree and be able to download it into a new machine and start running, and now know that you're starting from the consensus state of the chain without trusting any one provider. We can do the same with snapshots of the entire ecosystem of computing contracts running in the midst of their transactions of long-lived JavaScript programs, into state sync in Cosmos, so you can just start up a new node in minutes and be running. So those are sort of the bottom layer things. We also have implemented the core of the economy, right? The design of Agoric was to be able to deploy businesses that operate with a stablecoin, that pay gas with a stablecoin, and that are able to back the stablecoin with other collateral. The core of being able to build financial instruments is having a good oracle that can tell you the outside prices of things, the real-world prices of things. And so there is an oracle network for Agoric. It was driven by Simply Staking, who I know are floating around here with their entry point T-shirts. And it's using Chainlink tech underneath, and we've worked with Chainlink to make sure that they like this network and all those kinds of things. So it is a future extensible network where you can build smart contracts where one of the DeFi Legos is the price of stuff, which is really, really powerful. And then finally, we launched inter-protocol vaults. And I'm going to talk about these in reverse order, so I will take off my Agoric hat and put on my inter-protocol hat and go on here. All right, so inter-protocol. Most of you have heard of this. It is an over-collateralized stablecoin for the Cosmos ecosystem. Vaults are the MakerDAO style vaults, right? Vaults are bring Atom over IBC. In the future, bring Osmo, Staked Atom, Wrapped BTC, Wrapped ETH, ST, all of these things, anything that is potentially reachable over the Interchain, bring it over as collateral, and mint IST against it, right? Or, originally the first version of this launched last November, so IST has been out there on Osmosis, on Crescent, on Shadeswap, where you could bring USDC, USDT, or DAI bridged over Gravity or Axelar to buy IST. So it's out there, it's being integrated in applications already. But what launched in June is the vaults. And that's really the big core of it, where it unlocks the billions of dollars in asset value that we've all built across numerous chains. So now you can leverage it to get IST, to get something where you can mint IST and swap on Osmosis, right? And you can have a sequence where you can just do that all, and people are starting to add UIs where you'll be able to do that in one click. Now, I will say, mentioning that, Osmosis just, I think, passed the governance vote to add several gas tokens to Osmosis, of which IST is the native stablecoin, the native stable token for Cosmos that is now able to be used as gas on Osmosis, which means, again, mint and swap. You can bring your Atom over, mint some IST, take it over to Osmosis, and just buy stuff. Right? You don't need Osmo, you don't need another account, you can just do it. So awesome stuff. And it's all, it was all originally designed to be IBC native, to use the assets that we've created, that you've created, that other chains have created, and bring them all together into an economy. And I could say a lot more about that, but I'm instead going to use that to talk about programmability. So now, with my Agoric hat back on. So, the key to vaults, right? They are over-collateralized vaults, right? Where I bring in, $2,000 of Atom and I mint $1,000 of IST. And if Atom were to fall that much, which of course it will not do, but it's volatile, some probability, right? Where Atom where if the asset falls in value, for a period of time before climbing back up, the vault system needs to sell it to cover the amount of IST that was minted against that asset, right? And so that you've got an Oracle network, it has to signal into the network, you have to have smart contracts that respond to it, something has to be driving this, and then based on this, the vaults that are determined have to get sent to the liquidator to be liquidated. And that turns out in many systems to be complicated, fragile, and et cetera. What does that look like in JavaScript? What would a JavaScript programmer, one of the millions of programmers out there that program asynchronous systems every day in JavaScript, what would they expect? And what can you do on Agoric? So what's going on here, right? I don't know if you can see a laser. All right, price authority. That's what we call the Oracle. There's reasons for it, and they don't matter. It's just price authority. This is saying, return me a promise when the price of the collateral I've got is lower than the liquidation trigger value. That's it. That was the semantics I wanted, and I get this promise and I just await it. And now this will just pause and sit there and it'll go swap out to disk or whatever it does, but it'll hang out for 3 days or a week or a month. And it's when that promise resolves, it resolves because that Oracle network that we mentioned, it signaled in, it came to consensus, it computed the median so that one weird price doesn't all screw it up, right? And it will then propagate up, and this contract that just said this simple line with this DeFi Lego, which is a price, suddenly will resolve this promise. It will go on, and it will go, yeah, I'm going to call liquidate. I'm going to hand this vault off to the liquidator, right? So that, too, is, here it's returning the promise. This is inside an async function, so this liquidate function is async, and behind the scenes it's doing something async. You don't care. You know how to compose that stuff in JavaScript. This is what people expect, right? So what does that liquidate look like? Well, this was an element of the liquidate. This is somewhere down inside the code. And these are all code samples slightly cleaned up to be easier for you, minus comments, minus some error handling, just to make it easier. But the fundamental here is an offer. In Agoric, it's been offers since we talked about this in 2019, I think it was. You may now hear a lot about those kinds of ideas under the name intents, right? So what's an offer? I've got to give. I'm the vault. I've got a debt I've got to cover. I will give you this collateral, but only if you give me back that much IST, the debt that I need to cover. And if you can't do that, you don't get my collateral. Right. Now, I don't much care, what the contract is here. I mean, I do because I would like it to accomplish this goal. But no misbehavior by the contract, no upgrade of the contract, no rugging of the contract can take my collateral unless it gives me my debt, unless it pays me the IST that I'm asking for that will then cover the debt of this contract, right? Okay. So that's the basic offer model, and you'll note that, of course, that's async. This is just an async operation from one contract to another where all of our contracts can compose. And the fact that that happens to be on this chain versus another chain, well, you'll see that that doesn't matter very much either. Okay. So let's take another example with one of the teams we love to work with, Akash, right? They resell compute time on clouds in the Akash chain, and they're doing interesting and advanced features with GPUs for AI programming and all that. So they now have an audience of non-crypto folk, right? These are real use case for real users out there that need real value delivered by blockchain. Okay, and sorry you can't quite read that. That's saying, so one of the use cases for end users is I've got this job running, and if it runs out of money, it will be terminated. I don't want it to run out of money. I might have 20 of these jobs, and I would like to have a pool of money. I don't know which one's going to run out. I will dole out money in order to keep them all going. So this is query, fetch the account balance, and that's inside of that. That's triggered by an on-chain timer, right? JavaScript, you expect to be able to run things at a time. We can do that on our blockchain. If that number is below threshold, that's running inside the contract, then I want to deposit to that Akash account. This is all running on JavaScript. It's not currently running in production. This is one of our bounties, running in JavaScript on the Agoric chain, and where the payment is send money over IBC. That's the mechanism we had available. ICA was not there. What does that look like? Well, it kind of looks like what I just said. Make an async query to find out the funds that are inside of that particular Akash deployment, and just await that answer. And that might go to an Oracle. That might be an ICQ to query the chain over IBC. We don't care. That's just a function. It's abstracted. It's async. It all works. And then once I get that back, if it's less than my minimum threshold, then fund the Akash account. And that might be do a local transfer into a purse because the owner of that account has an account on Agoric and they're watching that. Or it might be send a IBC transaction to do a funds transfer. Or it might be reach over to Osmosis to unbund something, move the money. There's all these async things that are nicely abstracted away and fit all together where this contract running on the Agoric chain can just await those to finish. You've got this nice compositional thing that we expect out of other languages. I'll do a couple more, right? I mentioned the unbond, right? If I wanted to, on an Oracle price, unbond on Osmosis, unbond some atoms, transfer it over to the Cosmos Hub and stake it, that sounds like a complicated thing, except it's going to be a lot more. Well, I've expanded some of it. This is just await sending the ICA packet. And this is something that one of our developers on the platform, not at Agoric, one of our third-party developers built, right, is this send ICA packet. There's asynchronous function, bottoms out and send the ICA packet, and get a promise for the result. So if sending that ICA packet fails, as you would expect in JavaScript, this would throw an exception, and I can do try catch or whatever it is, right? And then here's one that's expanded, right? Send ICA packet to unbond, send an ICA packet to Osmosis to transfer this to the hub. And then finally here it's, create a delegate message, and this is expanded. This is sort of a very low-level representation to just send that ICA message, right? We can do any ICA thing that any chain can do. You can roll it up and abstract it in JavaScript. That's pretty cool. And in fact, they were, okay. So, and those are components. Some of these were built by bounty hunters on Agoric, or they're being built by the reference partners that are building applications to ship this quarter. So Calypso is an interchain trading terminal where it can, in one click, take assets from any chain, move convert them to USDC or whatever, move them over a bridge, have them land on a third chain and apply some application, right? So take some stuff on Aave, turn it into USDC, move it over Axelar, buy Atom and stake it, right? That turns out to be one of the key use cases that they see is I've got assets here, I want to do that thing over there, make it happen. I don't care, just make it happen in one click. All orchestrated by smart contracts on Agoric. Now these guys are also the ones that are building the MetaMask Cosmos Snap. Right? This is 30 million developers, 30 million users have MetaMask. we would like to have use cases where in some cases it's people that were already on Ethereum that we now want to invite over to awesome applications in the Cosmos space. It would be an obstacle if in order to do that they had to install another wallet, even if it was a better wallet. So, MetaMask Snaps uses the agoric JavaScript, the hardened JavaScript that I've talked about in other presentations. It uses that. It uses the same thing that lets us safely run third-party contracts in JavaScript to safely run arbitrary plugins to MetaMask, where they don't have to trust the code of the plugin because nothing it can do can escape the confined set of authority they give it in order to steal secrets, change the time, muck with balances, etc. And so that's being done by Joe Schnetzler of Mystic Labs, the people who are doing Calypso. They, in the process, they've done several of these async components, as have a few others here. And I brought this up because, like Fede, I think, wherever he is, I mentioned that, and he did not realize that it was using the hardened JavaScript that we built. And we've been working with MetaMask for 2 years on both the architecture and the elements they needed for hardened JavaScript in order to accomplish that goal. And the same hardened JavaScript is used, in Salesforce and in brokerage terminals and other things. So this is standards track safe JavaScript for building things that is the heart of our system. Okay. We also have Crya in the audience. Cread is a NFT application that they'll be showing off at Cosmoverse, and it's built on reusable components in an NFT toolkit that started with components we built, some that they built, and they're carrying it on beyond that. And then Crabble, I think there's some bite pitch folk around. Crabble is a rental application for NFTs with utility, of which multiple people building on the system are creating NFTs with utility, as are, Stargaze and others. And then, so these are things that are in Q3. We are working with these partners to ship these applications, to ship applications for third parties, for the general purpose platform on Agoric, and then roll out our developer program. So this is, our goal is Web 2 JavaScript developers are now able to build apps for Web 3. So we will be targeting those Web 2 developers with our DevRels program. This ability to do orchestration on the Interchain, that's for you. Right? That's what you guys are doing. And so I'm going to come back to that before I go away here, which is what orchestration would make valuable use of the services on your chain or on the assets your chain creates, right? We mentioned before the store your assets in an exchange until you need them on your chain, right? I can store my Akash in a pool. I need to pay for a service job that's running out of money, move it over, transfer it over, and pay for the job. But DAO-driven software development is similar, right? I have a vote of my DAO. It now wants to publish some website. It can, with no human intervention, start up a job, launch the website hosted by Akash. I love the real-world use case of, that when it's done. It was Jack Zamplin that was saying. So, in summary, what you're saying is I can just await Akash.setup compute service and then deploy some stuff. And the answer is, yeah, someone needs to build that component. So someone out there build that component. And then in another example, right, I mentioned the Cread is doing, and Crya is doing interesting, nested, and other kinds of novel NFTs for lots of different use cases. But they've got interesting metadata that's got to be stored somewhere. Well, if you wanted to store them in IPFS, that's awesome. But are you sure they're going to be there next month? Not unless you pay for it, and that's what Filecoin is for, with the Axelar integration, with the GMP integration, which one of the third-party developers built. Is this lovely async GMP integration where you can't, am I sending over ICA, am I sending locally, or am I sending over GMP? We don't care. It's all async. And so you could reach over GMP to Filecoin, fund a storage reserve, and then from a smart contract on Agoric, put your stuff there, right? Okay. So what can we do with your assets? What use case do you want? Find someone with a red hat or a yellow hat, because they're the IST folk, and tell us what you need. So thank you very much. Come check out the QR code, which has a bunch of pointers to interesting components that other people have already built, DeFi Legos, governance Legos, NFT Legos, and come talk to us. We're excited.
Thanks, Dean. So today's a very special day, not only because it's the launch of Nebular Summit Day 2, but also because it's my business partner's birthday. Clément, co-founder of Interop Ventures, please come on stage. Come. All right, so we're going to sing happy birthday to Clément in French. So it goes like this. Joyeux anniversaire. Joyeux anniversaire. Joyeux anniversaire, Clément. Joyeux anniversaire.
Thank you very much.
Happy birthday.
Thanks.
Yeah. That's right, I've got one. Thank you. Now get off the stage. Hurry up. Awesome. Right, now for the next presentation. Yes, just over there. Perfect. Right, can we please welcome to the stage co-founder, CEO of Quicksilver, Roia Mortaki. Come on, get yourself up here. But if you keep it to your chin, then everyone can hear you. That's the, yeah, you keep going to that. Right. Good luck.
Hello everyone, thank you for being here today. My name is Roya, I am co-founder of Quicksilver, Interchain liquid staking protocol for Cosmos. I am also co-founder of Ingenuity, which is the development company building and maintaining Quicksilver. So at Ingenuity, we are a global team of 10 people, and we also have a few hardworking interns. Maintaining Quicksilver and keeping it secure truly takes a village. And so in addition to our various partners and community contributors, Quicksilver is also supported by Orishtech and Notional. So just wanted to give these teams a proper shout out for their hard work. A lot has been said and done about liquid staking in Cosmos in the past year or so. And I've been thinking about what could be the best ways for me to contribute to that ongoing conversation. Firstly, as a non-technical founder that really cannot go into the technical details of the implementations, but also, and perhaps more interestingly, as someone that's been, that's had a front row seat into the inception and the unfolding of the liquid staking game over several years and across multiple ecosystems. So today with you, I'd like to go into sort of like what the design space of liquid staking looks like today. Why did you converge into that model? And also, like, what could be potentially, like the challenges that will arise from that model. So I give you fantastic challenges and where to find them, the crimes of liquid staking. It is a bit of a dramatic title, but after all, I am French and we are in Paris, so this is the perfect opportunity to embrace drama together. So how did we get here? Over the past few years, all liquids, or like most liquid staking protocols, and it really does not matter which ecosystem we are considering, by the way, most of these protocols had a tendency to sort of converge toward a certain model, and that model, or like that design space, had three main principles, or rather characteristics. So the first one is fungibility and the ability for liquid staking tokens to be, fungible between each other, even though they were minted through different validators. The second main characteristic is the redemption rate model, where the liquid staking token is basically a redemption rate token that accrues value through its redemption rate. And basically, you only realize your rewards once you exit the protocol. And finally, the last characteristic that was predominantly used is the validator whitelist model, which is, liquid staking protocols curating a subset of validators and allocating stake to them. And these three characteristics sort of were the predominant characteristics of most liquid staking models for a reason, because, they solved for some of the biggest pain points of liquid staking. So they solved for, the DeFi usability. They also solved for the issue of distributing rewards. And they also kind of solved for slashing or for risk mitigation, generally speaking. And by the way, if you want to learn more about this, there's a really great report from Chorus One that was published back in 2020. It's a liquid staking report. It's really cool, and it's still very relevant to this day. So if you want to learn more, do take a look at it. I believe also the other sort of important thing to keep in mind with regard to liquid staking design is that in parallel to this, each new generation of liquid staking provider came and sort of built on what came before it and gave liquid staking a new flavor. So for example, Lido, not only did they solve the distribution or the delivery problem of staking rewards by creating a value accruing token or the redemption rate token, but they were also hyper-focused on slashing, or rather on not experiencing slashing. Then Marinade was hyper-focused on absolute decentralization. And with Quicksilver, we are trying to achieve all of this, all while maintaining user sovereignty, which is really important in our opinion, especially in an ecosystem like Cosmos. And if you want to learn more about how we plan to achieve that, there's plenty of information in our documentation and a lot of blog posts, so do feel free to check that out as well. So basically, this is what the design space of liquid staking converged towards in the last few years. But this has not been without criticism, and it did lead us to a sort of challenges that we are facing today, and some of which we might also come to face in the future. And now I want to explore these with you. So obviously, the first and perhaps most obvious challenge is centralization. I think that today we have enough hindsight to sort of acknowledge that, unfortunately, liquid staking has been a centralizing force in proof-of-stake ecosystems. So, for example, around 30% of ETH is staked through Lido across something like 29 validators, which I think we can all agree that it's not a very desirable outcome. To their credit, the Lido team has been trying to address that and to address, the issue of stake distribution with some initiatives like the Lido V2 upgrade. But the conclusion here is that, stake centralization is something that is very, very hard to try to address retrospectively. So this is the issue of centralization at the validator set level. The argument can be made that centralization can also be viewed at the level of the liquid staking provider, where we could evolve to a situation where a disproportionate amount of stake is also concentrated with a handful of liquid staking providers. And recently in Cosmos, and especially at the level of the Cosmos Hub, we have seen sort of a lot of community conversations and attempts to, regulate, for lack of a better word, regulate the use of liquid staking and try to make it safer and better for users. And trying to address centralization could be one of the topics discussed there. The other sort of challenge that we also see has to do with the consensus model of proof of stake ecosystems. So here it's important to understand that delegated proof of stake has an economic model of validator competition. So validators compete with each other for the stake of delegators, and by doing that, they are not just infrastructure providers. They provide a lot of value and a lot of services to the chains and the ecosystems that they validate on. They produce content, they educate the community, they participate in governance. They do a lot of cool stuff that also make them, economic actors at the level of these chains and these ecosystems. And the potential issue here is that liquid staking providers, as sort of, go between delegators and validators, kind of ignores this, this economic arrangement between delegators and validators that is really at the heart of delegated proof of stake. And we could even evolve to situations where there could also be some misaligned incentives there. So the thing here is that we are at a crossroad of sorts, and each path has its kind of trade-offs. So we could try to figure out and evolve towards liquid staking models and designs that do take into consideration the very complex and the very various the various economic arrangements between delegators and validators, or at the very least, we need to be cognizant of the dynamics that are at play here and how they can kind of influence the consensus at the level of, the chains and the ecosystems. Yes, another big one here is redemption rates. So as I mentioned before, a redemption rate token is a token that accrues value over time, and you only realize that value once you exit that position. All liquid staking tokens are redemption rate tokens. The other thing also is that you have to keep track of the evolution of that redemption rate. And honestly, whichever way you look at it, it's just very bad user experience. The other thing with redemption rates is that today, most DeFi protocols have to query the redemption rate in some way or form. And usually the redemption rate is queried via oracles, which are not cryptographically verified. And I think we can all agree that that also is not a very ideal situation, because it adds an additional and unnecessary layer of risk there. So one way to go about it could be getting rid of the redemption rate model entirely, and having, a fixed redemption rate between the asset and the liquid staked asset. So that would be a much better user experience for the user. And also it would be better for DeFi integrations as well, because they wouldn't need to keep querying redemption rates. Now a big one, governance. So especially in an ecosystem like Cosmos, right? The issue today with liquid staking is that if you decide to engage in liquid staking, whether you are, an individual user or an institutional, if you engage in liquid staking, it means that you need to leave your governance participation rights at the door. And we can understand how that can be very limiting in an ecosystem like Cosmos. Now, thankfully, all the chain-agnostic liquid staking protocols today have a plan to sort of address that and make governance possible with liquid staking in some way or form. But even considering that, we talked earlier about the issue of potential centralization with liquid staking. If we believe that to be true, then we are going to be facing a concentration of, governance power as well. Now, the final challenge that I'd like to bring forward is silos everywhere, cross-chain nowhere. Again, this is just a very dramatic way of saying that we need to try to focus more on an interchain user experience for users in Cosmos. So, for example, the unbonding periods are really limiting the uptake of liquid staking in Cosmos. Of course, there's the liquidity staking module that is developed by iClusion, and that is going to be, it's highly expected, and it's going to be enabled on the Cosmos Hub soon. And it's really expected to improve the user experience and to drive liquid staking adoption up. Now to the issue of the complex DeFi usability, especially as as a user today in Cosmos. So yeah, basically there's fragmentation is a well-known issue in our ecosystem, unfortunately. And it is something that we tried to think about pretty early on at Quicksilver, where, for example, on the user interface, we have a page where users can have one place to check all of their assets across all the multiple chains where they are liquid staking. And we also try to make it as easy, smooth, and simple as possible for users to, for example, transfer their liquid staked assets onto different chains, and so on and so forth. And I know there's a lot of other teams within Cosmos that are working on this. For example, the team at 42 Money is working on a UX aggregator where you can have a one point of entry to all your wallets or your staked positions, LP positions, and of course liquid staking opportunities, which is really great. I think that the team at Skip is also working on something really cool to sort of minimize the steps that it takes for a user to go through a DeFi user journey. So one cool user use case that we see for it with liquid staking is the ability for users to, for example, liquid stake an LP in one click, one transaction. So a lot of things are, being done to drive the needle forward in the right direction. So yeah, lots of potential challenges that we expect for the future. But the thing about challenges is that it's always better to, try to embrace them as opportunities. It's at least what we are trying to do at Quicksilver. Because Quicksilver really was born out of a genuine desire, not only to bring liquid staking to Cosmos, but also to try to address some of the biggest pain points that are brought forth by liquid staking, especially around user sovereignty, user choice, and governance, which is very important in an ecosystem like Cosmos. And so, today we are also trying to think about what are the next challenges, the next pain points, the next sort of frontier of liquid staking. And so, I want you to imagine with me, what if you could leverage liquid staking tokens that exist on other chains for governance? Or what if, risk no longer had to be socialized, or users no longer had to keep track of really painful redemption rates? Also, what if single entities could mint their own like customized liquid staking protocol based on their own preferences, their own risk profile, their own choices. So yeah, this is sort of what we expect are going to be like the next frontier for liquid staking protocols. And yeah, this is what we are currently also trying to work on, and that we'll be trying to sort of address through our product roadmap in the next year or so. So thank you so much for listening. Do connect with us if you want to keep this conversation going, and thank you very much.
Yep, freeze perfect. That's amazing. Thank you for that presentation. That was great. Let's move one over there a little bit. Right, next up we have a panel. So if I can welcome to the stage Mustafa Al-Bassam, who's the co-founder and CEO of Celestia. Also co-founder of Osmosis, Sunny Agarwal. And moderating this panel is Sam Cassett, who is, was it Analog Interchain? There we go. Right, let me give you one of these.
All right. Is everyone still awake? Barely? Okay. All right. All right. So I assume most of you know who these people are, but quick introductions.
Sure. Hey guys, my name is Sunny, one of the co-founders of Osmosis. It is a DEX in the Cosmos ecosystem, and I've been working in the Cosmos ecosystem for the last 6 years doing a bunch of different things.
My name is it on? Oh, there you go. Hello everyone, I'm Mustafa. I'm one of the co-founders at Celestia, which is a data availability layer that makes it possible to create shared security for rollups. And one of the things which we're doing as well is we have a project called Rollkit, which allows you to deploy Cosmos chains as rollups on Celestia, so that you can have so that Cosmos chains can have shared security.
All right, thank you. I think this audience is pretty buildery, so I'm going to just set the stage a little bit for where we're coming from for anyone who doesn't know. So, and then we'll get into some more juicy stuff. So, Sunny, maybe do you want to start? The original title of this was sort of app chains versus modularity, but I think there's a shift more towards mesh security modularity. Can you just spend a minute steel manning an app chain thesis, and maybe why did you choose to make Osmosis an app chain to begin with?
Yeah. So why did we choose to make Osmosis an app chain was we kind of realized that for the application that we wanted to build, a lot of the things we needed to do, we needed to go change the core blockchain, and we just wouldn't have been able to do what we wanted to building on a smart contracting platform, especially when you want to go do stuff around privacy or MEV resistance, and these are things where privacy, you need to go change the cryptography of the blockchain. I don't have the ability to do that in Ethereum without engaging in multi-year-long EIP debates, or if I want to go change how the mempool works, it's I can't go do that on Ethereum. While with an app chain, I can go touch all of these core parts of the protocol without having to ask for permission from anyone, and I can make the blockchain up. Ethereum has to be credibly neutral, or any generalized L1 has to be credibly neutral towards the applications built on top. Osmosis does not need to be. It could be oh, we want to reserve a certain portion of our block space only for Osmosis trades. We can do that. We want to be any liquidity add transactions have to go before any trade, so you can't like rug liquidity before someone's trade. We can go do that. So, it was all of these sorts of things where like building an app chain was the way to a fully vertically integrated stack gives the best features and UX that we wanted to build.
Makes sense. So in that vertically integrated stack, obviously you need validators. The model of validation is evolving rapidly within the Cosmos ecosystem. How would you define, and looking forward to contrasting it with Celestia and rollups and that security model, how would you describe the security model of Osmosis in the context of its validator infrastructure, interchain security, mesh security, and how do you see that evolving?
Yeah, so Osmosis started off like every typical proof-of-stake chain where it was using, it had its own native token called Osmo, used in a proof-of-stake system, similar to every Cosmos chain today. Then the next big change to Osmosis's security model came with this thing called superfluid staking, where we said, hey, beyond just Osmo, why can't we actually use the DeFi assets built on top of the chain, most of which are backed by Osmo, have Osmo underlying them, in the DeFi protocol, in the proof-of-stake protocol itself. So what you could do, what we started with was LP shares. So you could say, if I have an Osmo Atom LP share, that has real Osmo underlying it. I can take the LP share itself and use it in the proof-of-stake protocol. And the protocol is smart enough, it understands the LP shares, so it could be like, oh yeah, this LP share, we know it's worth roughly this much Osmo, and we're going to provide this much of an additional discount risk factor on top of it. And so yeah, that's how that came about. Then, that was, if you think about it, superfluid staking is sort of this like proto version of mesh security, where mesh security, I assume most people here are pretty familiar with it, so I'm not going to go too much into it. If I need to, let me know. But it's this idea that, hey, why can't we use other tokens as well as helping secure our chain? So things that we have these deep economic relationships with, something like Axel from the Axelar chain, or Mars tokens from the Mars chain. These are things that we are very economically interdependent on. We should allow all of them to be also used to secure Osmosis. So now it's like, you can use base Osmo, or you can use DeFi assets on the Osmosis chain, or you can use staked assets on other chains, all to contribute to Osmosis' economic security.
All right, so here's a weird one. Is there any world in which Osmosis would be an L3?
We're not even in L2 yet, so what does it mean to be an what would it mean to be an L3?
Like an app chain on top of an L2 that gives you some degree of freedom to do design considerations like you were just describing, but not have its own validator set.
Yeah, I think having long term, we should be all Cosmos SDK chains should be generating fraud or validity proofs, right? I think Rollkit is actually making progress towards that. And so if the question is should we be generating these fraud proofs and using them in our communications with other chains, then the answer is yes. Should we get rid of a decentralized validator set? No, because we still, our take is that fraud and validity proofs gives you safety. Single sequencers still don't give you liveness guarantees or censorship resistance guarantees. And for those, for liveness, you want some sort of decentralized validator set. For censorship and resistance, the best solution that we know of is threshold decryption. And it's in the name. You need some threshold over which to do the decryption over. And for that, a Tendermint consensus protocol is a pretty good way of coordinating a threshold decryption protocol.
Yep. Any comments on that, Mustafa?
Okay, so now it's my turn. So let me start from explaining what we're trying to achieve at Celestia from the beginning. So the reason why we started Celestia is because we saw that the Cosmos vision is it's a fantastic vision of having an interchain of hundreds or potentially thousands or even millions of interconnected chains. And this was kind of the antithesis to the original Ethereum scaling roadmap at the time, which was just like one big chain that was sharded, was this Cosmos was like, okay, anyone can just create their own chain. But the problem that we saw with that was that with IBC specifically, if you imagine a world where millions of chains, which is very feasible, like there's millions of websites, there could be millions of chains, we're very early, it's not feasible to rely on committee-based assumptions for interchain bridging because you're fragmenting security across millions of chains, right? And it's just not a very sound security assumption. So ideally, what we want to do with rollups is replace the committee-based assumption, right, with a fraud or ZK proofs and data availability sampling. And because you no longer need crypto-economic assumption or committee-based assumption for bridging, you can the rollups can now have security without any kind of like sort of big capital upfront cost. And specifically, if those rollups all use the same data layer, they can all have a uniform level of shared security, right? So it's no longer like different chains have different levels of security. All the rollups have the same level of security because they inherit consensus and data, and ordering from the base layer. But that being said, I also like think that it's a I think people should also be free if they create their own chains with their own validator set. Like I'm also not against that. And if people want to use mesh security, they can do that. Like I think it makes sense for some use cases, and adding fraud proofs, would make that even better. Yeah.
So that makes a lot of sense. I think there's definitely room for both right now, and but I think we need to get a little bit into the distinction between those things and how they might conflict. First, I want to talk about. I know you announced something recently, Sunny. The collaboration between Celestia and Osmosis. Do you want to say anything about that? Tia.
Oh yeah, I mean it's not. It's Osmosis is interested in being the interchain DEX and trying to provide interchain. Part of the modular stack is that like not every chain, not every rollup needs every service on top of it. Osmosis has the most developed DeFi ecosystem in the Cosmos ecosystem, and like as more and more rollups come onto Celestia, like a lot of them focus on things like gaming, like the Argus stuff. Like instead of them having to have their own AMMs and DEXs, like we're working on a bunch of different toolings and things to make it so they can use Osmosis as their primary trading venue, while still like keeping their rollups like focused on their use cases. And then as part of that, what we're doing is like making sure it's very easy to bridge TIA onto the rest of these rollups, right? Because they need to pay for data availability, and I'm a strong believer in that you need to have like protocol-owned treasuries paying for this core infrastructure rather than allowing dev teams and foundations to do that. You had this situation on Arbitrum a few months ago where like the dev team failed to pay the DA costs on fund the wallet on Ethereum that paid for the DA costs, and like the chain came to a halt, right? So instead, you want systems where like, maybe Argus could pay in its own native token, it'll swap for TIA on Osmosis and pay for the DA on Celestia. So yeah, we're basically just building up a lot of tooling to enable the trading, the transportation routes for TIA throughout the ecosystem.
Very cool. So I want to talk a little bit about where these sort of models conflict, right? So, and maybe under what circumstances is an honest majority of validators in your own validator set like better or worse than having a roll-up and a different kind of like shared set of security assumptions, right? So Chorus One recently put out this analysis where they showed that as validation becomes more expensive, as you secure more chains in an ICS kind of model, it might price out smaller validators, or they'll cut corners and be just less good at it. We end up with less security. What's your opinion on that?
So I guess like my general take on this whole framing of rollups versus mesh security as well is it's like like I said, rollups provide you proofs for certain types of things, right? They can prove that like, oh, the state transition function of your system was valid, and you can prove that to something or someone. At the end of the day, you're still, most of this idea of L2s and L3s and stuff, you're proving it at the end of the day to some L1, right? And at the end of the day, that L1 is still secured by economic security and nothing else, right? Ethereum, at the end of the day, its security model comes from economic security. It's not a roll-up to anything else, right? And so the goal of mesh security is how do we maximize the amount of economic security of system. So would Ethereum be better off secured by just ETH or secured by ETH and the entire ecosystem of of DeFi assets built on top of it, right? The same way Osmosis is more secure with superfluid staking than without superfluid staking. There's other things, it doesn't only have to be for your base settlement layer. It could be for things like your Oracle network, right? Like, how do you generate validity ZK proofs so that an Oracle is correct? No, right? At the end of the day, Oracle networks are secured by economic security. Would you be happier with an Oracle secured only by Link token, or would you be happier with an Oracle network secured by Link token and Aave token and Maker token and Comp token? Like, everyone who's using something should provide security for it, and you have this more resilient, decentralized economic backing for these like core parts of the protocols that you can't generate validity proofs for.
Yeah. And so, Mustafa, in a world where sort of Celestia is at the bottom of that stack, what do you think are the forces that might act against that might select for rollups instead of having that validator architecture?
Yeah, well, sorry, my phone dropped off the floor, but it's okay. So I think there's some important nuances. It's true, like base layers like Celestia and ETH, they rely on economic security for censorship resistance, but not for state validity. Whereas like Interchain, IBC, and presumably mesh security, they rely on economic security to prevent invalid state transitions, not just for the censorship resistance, right?
No, so mesh security, it is just a protocol for people to add slashing conditions to actions, right? So it is implemented as an interface that you can write arbitrary slasher contracts for. The initial contract that we wrote is for Tendermint consensus proofs, fraud proofs, right? But we're going to write a contract for oracles, right? Where it'll be like, oh, here's this Oracle network, and like if you provide an Oracle update that's too far away from everyone else's, that is a slashing condition. So the idea of mesh security framework is just a model for adding up economic securities. What you apply that economic security to is up to.
But I guess, but for like the fraud proof stuff, you don't want to wait for a challenge period, right? You just want to slash. Mm-hmm. Yeah.
That's up to the chain, right? Like so. Some chains might say, oh, we want to wait a challenge fraud proof window before we accept IBC packets, right? Let's say 2 rollkit chains, they might want to wait the fraud proof challenge window, right? For Osmosis, from our product perspective, one of the things people love about us is that you can deposit assets in a matter of seconds, and increasing that to minutes or hours to accommodate these challenge proof windows, it's like, yes, it is better from a security perspective, but unfortunately, it just harms our product user experience that we have to weigh those things against each other.
Yeah, and that makes sense, but I will also say that you can have a significantly shorter challenge period if you make the fraud proofs distributed peer-to-peer and not on-chain. Because the main reason why Ethereum has a long challenge period is because you have to wait for the fraud to get on-chain, or if you use ZK proofs, then you don't even need to do that. But I mean, sure, it makes sense for mesh security as a general model to add certain extra crypto economic security for certain slashing modules, or slashing conditions. I guess just from my viewpoint, I would say I would see it depends on how many chains there are in the interchain long term, but what we're trying to achieve is a kind of a scenario where someone can just spin up a roll-up chain in 2 seconds, and bootstrap it without any crypto economic security. So we want to try and create a world where deploying a rollup chain, as a rollup Cosmos chain, for example, is easier and more convenient than deploying a new smart contract. Like the same way that like deploying a virtual machine on the on AWS is better and more convenient than using Squarespace, to launch a website, for example.
Yeah. So exactly, I think that the roll-up model makes it very good, making it as easy as possible to deploy like a state machine is great. But where mesh security is coming in is like, okay, most applications have other things they need to be correct other than just the state transition function, right? If you have a shared sequencer system or some sequencer system, you want some economic security guarantees around your censorship resistance mechanism.
So yeah, I mean, it's definitely true that a lot of rollups these days aren't very censorship resistant, but it's also like some important nuances there, because a lot of people think that you need a decentralized. Some people think, okay, well, you're basically reinventing blockchains by needing decentralized sequence set for rollups. But there's various designs that don't really require a decentralized sequence set. For example, like there's this thing called base rollups, where you're basically there's no sequence at all. You're just using whatever, however the blocks are ordered on the base layer. So you're using the base layer for sequencing. That does leak MEV to the base layer, but ultimately, the ultimate goal, even if you have a centralized sequencer, you can still inherit security from the base layer by having like a way to force inclusion of transactions.
Yeah.
But I'll say, that being said, like I'm not against like mesh security being used. Like I can also see models where rollups can have a decentralized sequencer set, and I'm not against like mesh security being used to add like bonding, add some kind of bond to become a sequencer in the security sequencing set, especially if that rollup doesn't want to have a token yet.
Yeah, exactly. And yeah, the force inclusion stuff I think works. It is just a little bit slower, right? Like it's not. And then the base rollups I think work. So base rollups, for anyone who's not familiar, is the idea that instead of submitting transactions to the sequencer, you instead you use your DA layer as your sequencer as well. So you submit transactions directly to Celestia, and the job of the sequencers or state machines is to read the transactions from the DA layer directly and construct the blocks on top of that, which I think works for some use cases. It's as you get more advanced in your use cases, the kinds of stuff that we invented ABCI++ for, it becomes more complicated. You might want to say that here's certain types of transactions that we submitted encrypted, but our validators are using vote extensions to provide price oracle data, but we don't want these things to be decrypted unless the price oracle data has come in, right? And so once you get into these complex workflows, it really, using a base rollup that is not fully programmable becomes kind of harder, and at that point you kind of just do want your own decentralized sequencer system.
Yeah, I mean, I guess with the threshold mempool stuff, that's kind of for censorship resistance as well, right? Yeah, I mean, there's definitely trade-offs between having either a base rollup, a centralized sequencer, or decentralized sequencing.
It's more about programmatic decryption, where it's I only want this decrypted in these scenarios.
Right. Yeah, I mean, there's definitely trade-offs between, and it definitely makes sense in many use cases to have a decentralized sequencer set, especially if you want greater guarantees around the threshold decryption and also other things more trust minimized soft finality guarantees.
So let's push into that a little bit. So one of the criticisms if you're a dev deciding how to architect your platform, one of the things you're thinking about is actually cost, right? So there's some criticism that having your own validator set costs a lot. You have to have emissions over time, et cetera. Within the rollup model, in the modular model, sounds like there are there's an increasing number of things you have to pay for, right? You have to pay for potentially sequencing, you have to pay for DA, maybe there are other things that we don't even know about that you're gonna have to pay for as things become more modular. Are there any sort of first principles arguments you can make about which one is gonna be cheaper over time?
I think there's different types of costs that exist, right? Something like DA, I think there's a pretty strong argument that there's like economies of scale to it because of like how like the encoding in Celestia works. Like the more data that you get, it's better to have. There are economies of scale of having one DA like layer that does the reach element encoding versus like many separated ones, right? The other one though as well is like just on like engineering costs, right? Like Osmosis took some chains in Cosmos decided to build their own bridges, right? Like Injective has their own bridge to Ethereum, or Sif Chain built their own bridge to Ethereum. For us, we took the take that like building bridges is hard and a lot of from the security perspective and engineering perspective, and we just don't want to do that, and we would rather work with a team basically outsource it to them, right? And so that's the other thing that you also have to think about.
Didn't you tweet once something like as an Asian, I don't like to what was it?
This was Leland's tweet, I think. He's like something about that. It's like the entire Cosmos thesis comes down to I don't want to pay for stuff or something.
So on in the Celestia model, do you have an opinion, or is the stack itself opinionated about how those costs are structured? Have you thought about that in your design?
Yeah, I mean the way that to use an analogy, the way I would compare it is launching your own Cosmos chain is like having your own physical server and maintaining buying a physical server, co-locating it in a data center and maintaining that. Whereas using rollups is kind of like just using AWS on the cloud. The server has higher upfront capital costs, and you need higher labor, potential labor costs. You need someone to maintain it. Whereas the cloud, it might be more expensive on a not even necessarily more expensive, but at a certain scale, if you're like a big corporation, it might be more expensive. But for most people, it's cheaper and also there's less upfront cost. You're just paying. It's like pay as you go. So that's kind of the way I would compare it there. But from Celestia's perspective, all you have to pay for on Celestia is the data, and that's pretty much it. You're paying per byte. It's pay as you go.
Yeah. Makes sense. I guess Mustafa, can you say a little bit about the validator architecture that Celestia has chosen, right? And I'm trying to relate this back to what we were talking about before in sort of Chorus One's analysis of the more things that you're validating, the higher the cost, and that potentially being a centralizing force. So say I'm a validator on Celestia, and say I've already developed this specialized infrastructure to provide DA, right? That's optimized for that. Maybe I also provide EigenDA. Maybe I do Polygon's DA, et cetera. Are you concerned at all about that becoming a centralizing force in validator architecture, and how have you thought about that?
Yeah, I mean, centralization in block production and validator infrastructure is a kind of a huge general problem in blockchains. I don't really know if anyone's truly really managed to solve it on a long-term perspective. To me, proof of stake is basically flawed due to liquid staking. At least the current iterations of proof of stake. Liquid staking kind of creates natural monopolies. But the way I see it is that the kind of the end game is we want to try to create systems where the end user can verify the correctness of the chain even if block production is centralized. But using proof-based systems like fraud proofs and ZK proofs, you don't have to trust the validator for the correctness of the state validity of the chain. In some cases, you might have to trust them for censorship resistance, but there's various ways of trying to increase censorship resistance in the presence of a centralized validator set. Things like proposer block separation, auction models, and also threshold mempool encryption.
All right, you got 90 seconds each. What's your most outrageous prediction for how blockchain architecture is going to change in the next 2 years?
I mean, I don't really know. I hope this isn't outrageous because this is Nebular Summit, but I think there's going to be millions of chains, in a few years' time. Because we want to make deploying app chains easier than deploying a smart contract.
Sonny?
Is it something I think will happen or what I want to happen?
Either one, but whatever would be most exciting.
I think we move away from proof of stake entirely, and we move towards like new sorts of like Sybil resistance systems. I'm a big fan of reputation, like web of trust based consensus protocols, and I think proof of stake had a lot of superiorities over proof of work, which is why I spent years working on it. But I think it has flaws, and I think that there is a world where we can build better things than proof of stake. And so I would hope that like 5 years from now that our primary blockchains are not running on proof of stake, but are rather running on these like web of trust based consensus protocols.
Do you think?
How about like proof of personhood using WorldCoin? Like proof of orb? Maybe that's.
I guess like what I'm looking for is something that like decentralized identity systems that not using WorldCoin, but like using a web of trust to get some sort of pseudo identity system.
Yeah, I guess some sort of proof of personhood or some type of proof of personhood super resistance mechanism in some way.
Do you think we ever connect back to Bitcoin?
Oh yeah, I mean this is why Babylon exists, right? Like I think that another hot take, which I think is probably going to be true, is a lot of Cosmos ecosystem chains are going to be secured by Bitcoin restaking.
Cool. All right. Super interesting, guys. Thank you very much.
Thank you.
Appreciate it.
Awesome. Hello, hello. 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 There we go. I'm back. Awesome. There we go. That was the last panel of the day. Now, please stay awake for another half an hour. We've got one more presentation to go. And I'd like to present to the stage CEO of Blockless, Butian Lee. Can we give her a warm welcome, please? Did you give them anything? It's better if we use this. This is your technical man. This is your technical We'll be ready in 2 minutes, or 30 seconds, hopefully. There we go. We're good to go. Now, the last presentation of the night.
Thank you. Hi, everyone. I'm Bu Tian, co-founder and CEO of Blockless. We provide full-stack ZK verifiable decentralization for builders to create, manage, and scale decentralized applications, networks, and subnetworks. So a few days ago, someone sent in our Slack, what I'm listening to channel, this hip-hop song from the Naughties by Tidra Moses. It's a wonderful song. Definitely give it a listen when you're out of here, called Complex Simplicity. So, you know, in this nascent technology, the industry that we are building with crypto, like new tech is sort of knocking on the door every day for public consciousness. It's so easy for us to look only inward for inspiration. You know, profile pictures has to be cartoon NFTs, AI, music has to be AI generated, and settling debts with friends has to be done on-chain. However, the external world still has its merits. I'm sure that Tidra wasn't really talking about the tech world, and this definition of complex simplicity is a little vague. So what does it really mean? This complex simplicity in the context of the crypto world. You know, we're often so focused on building in decentralized ways. We talk a lot about governing in decentralized ways. But what it really means is that we have to overcome the hurdles of achieving full-stack decentralization. So despite all the things that this guy has done wrong, he was at least correct in pointing out what he has done wrong himself. Centralization, especially in the decentralized world, is very, very dangerous. But building a decentralized platform is often associated with a lot more complexities comparing to its centralized counterparts. So when we are looking into the decentralized world with protocols building very complex systems, you know, achieving full-stack decentralization for both on-chain and off-chain is often the harder things to do. When centralized solutions were presented to us as the easy and lazy option, your competitors may be skeptical about full-stack decentralization, about the ROIs, and your investors may be not, and their eyes may be glazed over a little about the idea of full-stack decentralization. So we realize that we are tasked with sort of the inverse of complex simplicity, which is to make this harder to achieve things simple and accessible for everyone. Taking from the hard-to-source compute power to managing the network security, you know, managing the nodes, behaviors, and handling privacy and everything. What we are tasked with is really taking all those and condensing that to a few clicks and make it easy for anyone to build a full-stack decentralized application. So instead of that complex simplicity, what we are delivering is really simple complexity for you to create, manage, and scale your decentralized application easily. Well, before I dive deeper into the solution that we provide, I'd like to just talk a bit more about the problems that we've solved and created that really brought us to where we are here today. Before we achieve on-chain decentralization, you know, well, people are mostly cynical when we talk about history of any sort. But Tim Berners-Lee is really rightfully the pioneer that has this idea of the online, you know, having this read and write format of the internet. Although his idea was sort of hijacked by the commercialized use of this technology to provide for those people who see internet as a drive-through for information and providing a read-only format of the internet. What we achieved today and on the on-chain environment, it's sort of delivering the initial vision of the online, which is providing a trustless, permissionless access to a shared ledger. Well, I guess some of you might be wondering why on-premise, which was really what we started before achieving online, why is that 1 degree of decentralization further from today? So on-premise or on-prem really allow users, individuals, and community to have their local control of their private data, their access, and private computing, while also benefiting from this shared ledger, shared security, data, and also transparency. So really combining the benefit of both worlds. So that is really what our vision is for Blockless, to drive for becoming this global network, allowing anyone to build a decentralized application and allowing them to serve their users in a trust-minimized way. So let me ask this question. What do you think? Is full-stack decentralization impossible, or is just simply impractical? I'm sure that different people have different answers, but basically, developers are often tasked with answering a couple of questions when they are looking into building a decentralized application. For example, what consensus or proof mechanism should the network employ? How can we prevent nodes from leaking private information? How do I guarantee 24/7 network uptime? And how do I ensure network security? These are the complexities that's often involved with building a decentralized application. And these are the problems that we've solved for you at Blockless. So we divide our product offering into 3 segments. First, from custom-built node network solution that's tailored specifically for your ecosystem or network need. Currently, we are working with EigenLayer and Celo to provide greater security and improved stability of the network. And second is the community-owned infrastructure. This allows your community to run your front and back end in a decentralized, permissionless way. And which brings us further to the third option, which is the fully managed solution for a serverless experience. We provide both serverless functions for event-driven, sort of building like a smart contract logic, also combined with continuous solutions provided by the app engine, and actually have a demo for you to see how it works in motion. But basically, with all those, depending on how your need is and how, for your average person, the features is needed, you can find yourself fall into at a given point of the spectrum. And Blockless leverage WebAssembly or WASM and WebAssembly interface or so-called WASI. And this architecture allows us to get a few advantages. First is the ultra-portable nodes. So you can run a Blockless node on a web browser. That means you can run a node on your phone or your laptop and achieve front-end and back-end full-stack decentralization. For people from the community, it means that you can get fairly compensated for easily participating and contributing your hardware resources. And for builders out there, it means that you can achieve a fully decentralized global network to have your application backed by this network. So for early projects, this provides solve the cold start problem for providing a readily available large pool of your target users. And for mature or established projects, this allows a degree of further decentralization that was previously not achieved. Either for old or new projects, this offers all-around better performance for your application. And last but not least is hands-free scaling. So this is really the core and basics for the serverless experience that we provide. So your application can be built once and then deployed everywhere, where the fluctuation of the workload is automatically taken care by the lower level of infrastructure that we provide. Therefore, builders, you can focus your precious time in building your application logic without worrying about the underlying infrastructure and scaling. We also have an automatic orchestration achieved by this Cosmos-based orchestration chain. So this chain is kind of like running a Uber matchmaking algorithm that optimizes the allocation of the compute task to the available hardware resources. Thanks to WebAssembly, we can achieve accurate provision of a task hardware resource consumption prior to running the task. So the first layer is really distributed orchestration, which includes the handling of incoming tasks to the resource allocation, the scheduling, the management of the nodes, and also fault tolerance, and the monitoring of the execution. Combined with our advanced node selection algorithm and our reputation system, which I think is also a big deal for a lot of distributed on-chain and off-chain ecosystems, we make sure that the functions and the applications, once coming into the system, can be efficiently allocated and distributed to the suitable nodes based on the hardware requirements, functional requirements, and also geolocation requirements. So really ensuring a reliable execution in a decentralized network in a verifiable way. So I'd like to show just a quick demo of how this is achieved. This is our developer dashboard, where you can easily connect your GitHub repo. And those contain your application logic. So you can name your project. This is actually a previous demo that we did for the Celo chain. And you can select how many nodes you would like to mobilize to get involved in the execution of your task. And we have CK and dynamic consensus, such as Raft, PBFT, etc., to ensure the security and transparency of the execution. And with the integration of data availability layer, the layer 1 and layer 2s, and also decentralized storage solution and other integration options, you can easily pick and choose what's most suitable for your application needs. And then, after the configuration, hit deploy. Now, your application or your function is deployed to a global edge computing network. Based on the requirement, we do roll call across the entire network to source the most suitable nodes to get involved in executing the task based on your specification. And here you see that we've selected the nodes based on the requirements, and then roll call is complete. They are tasked with executing the logic per the instruction and form the consensus, or in the case of ZK, approve is attached to the execution result that's submitted to a layer 1 or your destination of the settlement where the finality is taken care. So what blocklists really enable is to give you a universal toolkit to build with ease to achieve your application specifications and requirements. So I'd like to show you just a very simple example. One client of ours that is using Blocklist to achieve full stack decentralization, Humans.ai. They are a AI data and marketplace that leverages pre-trained models and open source models and data sets to provide cutting-edge AI solutions. Some examples include those with private trained data to execute traits on your own device based on your personal preferences. And also for pharmaceutical uses, those Humans.ai people are actually here today. If you are interested, feel free to ask more questions about how their technology is revolutionizing the world that we live in today. But there are three basic premises that they would like to achieve. One is permissionless access to their platform and to the open source libraries. And second is verifiable AI executions. And third is privacy control of private data. So they leverage Blocklist. First is the secure sandbox environment to run AI models across a variety of different GPU and CPU. And second is the peer-to-peer network that provides permissionless access and also combined with the consensus and ZK to ensure the secure and correct execution of the model and the results. Obviously, all those cannot be achieved on a blockchain just because of the intensity of the compute of LLM and large data set with large parameters. So with the solution, Humans.ai is able to deliver end-to-end, fully decentralized platform for users that they serve. We think that decentralization should be easy, and it should be top to bottom, end-to-end, from back-end to front-end. So which really brings us to an incident that happened in the past few weeks, where multi-chain team, they tweet about getting help from GoDaddy to bring down their own website. This is just one example of the community governance without true community power. And with Blocklist, we're able to achieve both. So which really brings to this little tribute to the internet. One of our engineers actually did this as a side project to leverage the dynamic functions to allow anyone to easily launch and host a decentralized dynamic front end, which means that you can not only have your static assets and content hosted, but also dynamic functions rendered in to a decentralized network. So we've used this to build our own website. As a quick demo here, this is how you really leverage the CLI to build using the Blocklist sites as the template to launch your own website. So what you see here is basically after you install the SDK, you're able to select based on the templates, configure what you need for the render into the binaries of the TOML file that specify how many nodes you need, what are the dynamic as well as static data. All those are stored in the directory of IPFS or other storage, for example, S3. And after you specify the actions required by each node, and then you can deploy, you can build, and then deploy your site. Here, as the last step, it shows the deployment, building and deployment, actually. So this is really the this is our own website hosted by the Edge network of decentralized nodes. And it's the first ever in the industry to have a dynamically rendered front end hosted on a fully decentralized stack. So if you would like to know more about how you're able to leverage blockless solutions to build better, feel free to just scan the Linktree QR and come hang out with us. Thank you so much. And yeah, I'd like to say that it's just awesome to be in this space where I must have said a couple times, in this where the environment collaboration is both necessary and intentional. For those of us building towards some sort of vision of the decentralized future, we choose to collaborate, and the work that we've done actually require a degree of collaboration that wasn't previously needed before. So really appreciate everyone that's building in this, especially interchain interoperability using the modular tech stack to build on top of each other. Yeah, thank you so much.
Hello, hello. There we go. Thank you very much. Last presentation of the day. Just before Seb comes on and closes, I just wanted to personally thank all the attendees, the projects, sponsors, organisers. It's been an honour and a pleasure being here today, and I hope everyone enjoys day 2. And I will let Seb take the stage to finish day 1.
Thanks, Danny. Wow, that was a crazy day. I hope everybody enjoyed day 1. We had some hiccups, we had some issues, but we plowed through them and just kept going. So thanks everybody for being here. Thanks for your patience through those challenges this morning. So I was just checking with the team over at the front desk, and 400 people came through today. That's incredible. 400 people on a Monday after a whole week of crypto conferences came to Nebular Summit, and we expect even more people tomorrow. So thanks to everybody who's still here and still excited. I want to give a big thank you and a round of applause to Danny. Absolutely killing it as an MC. Thanks so much. Really appreciate it. And yeah, thanks again to all the sponsors. Neutron, DYDX, OKP4, Secret, CheckD, Agoric, Celestia, Chainflow, Juno, Care1, NIM, BPI France, Noland, Interchain Foundation, Kado, Polymer, Akash, Loop, Composable, Kira, and I think that's all the sponsors, but that's like tons of sponsors. But thank you to all the sponsors who are making this possible. We couldn't have done it without you. So that's it for day 1. Come back tomorrow. Come back with the same energy, and the happy hour, the sommelier happy hour tomorrow night, where we can all get drinks and wrap up Nebular together with some drinks. We're going to stick around for like another 15, 20, 30 minutes. Get some ice cream if you hadn't had ice cream. And yeah, have a good night. See you back here tomorrow. Thanks.